If you're preparing for GCSE Foundation Maths, then this is the video that's going to make the biggest difference to your grades. I've written a huge exam paper with 114 different questions covering every topic in the course. And in this video, I'm going to go through all of the solutions to all of those questions. You can find a link to this paper in this video's description. The best way to approach this is to try each of the questions yourself first, and then when you've done those, come back to this video to mark them. You'll find some you get right, and some you get wrong, but the ones you get wrong you can revise in more detail. I've even put a checklist of all of the topics at the front of the paper so you can keep track of your progress. To complete the paper fully, you're going to need all of these bits of equipment: a pen, a pencil, a ruler, a scientific calculator, a pair of compasses, a protractor, and some tracing paper. When you go through the paper, you'll encounter this symbol. If you see this on a question, then it's assessing a paper 1 topic. If that's the case, you cannot use and should not use your calculator. And before we begin, a brief disclaimer. Just watching this video is not enough to guarantee you're going to pass your exams. There are many videos on YouTube with people claiming you can pass your exams with a couple of hours of preparation, but this is just not the case. If this were the case, we'd just shut down schools and everyone would learn from YouTube. It's still an excellent resource, but you need to practice the topics that you struggle on in detail after doing this paper. In addition, whilst all of the topics are featured in this video, not all of the variations are. Most of the topics in the GCSE Maths course can be asked in a variety of different ways. I've included only one example of each topic in the paper, otherwise it would be ridiculously long. If you want to practice any of the topics in detail afterwards, I'd recommend checking out the other videos on my channel. And if you've done all of these things, the next best way to revise is doing past papers. If you head over to my website, firstclassmaths.com, you'll be able to find all of the past papers on there for you. And now we've got all of that out the way, it's time to go through the answers to the questions. Strap yourself in because this is going to be a long ride. For this question, we need to put some numbers in order, starting with the smallest. To do this, we're going to draw a number line. We put 0 in the middle, the positive numbers on the right, and the negative numbers on the left. Now we can just mark on each of the numbers we've been given in the question. So we have -4, 6, 0, -1, 5, and -3. Now the numbers that are further to the left are smaller, and the numbers that are further to the right are larger. So we can write these in order, starting with the smallest as -4, -3, -1, 0, 5, and 6. For the second part of the question, we need to put some decimals in order. In order to do this, I'm going to write out the numbers vertically, like this. You can see that not all of the numbers have the same amount of digits. What I'm going to do is fill in any of those blanks with 0 so that they all have 4 digits in total, like this. It's now very easy to compare the size of the numbers. You could almost read these as though they're normal numbers, like 430, 340, 400, and 334. They're obviously not these numbers, but it might help us to put them in order. So despite having the largest amount of digits, the smallest one is actually 0.334. So let's cross that one off. Then the next smallest is 0.34, and we can cross that one off. Then it's 0.4, so we cross that off, and the final one is 0.43. For the first part of this question, we need to round 927 to the nearest 10. If we look at the number 927, the number that's in the tens column is this 2 here. This means we put a line after the 2, and then we're going to check this 7 to decide if we round up or if we round down. 7 is 5 or more, so we're going to round up. That means the 2 will round up to a 3, and the 7 will become a 0. So to the nearest 10, this number is 930. For the second part of the question, we need to round to the nearest integer. The nearest integer just means the nearest whole number. So if we take the number, this time we're interested in the number in the units column since we're looking for whole numbers, that's this 7 here. So we put a line after this 7, and then check the next digit, that's this 5 here. If this number's 5 or more, we would round up, and if it's 4 or less, we round down. And it's 5, so we round up. This means the 7 is going to round up to an 8. So the number that this is nearest to that's an integer is 18. For this question, we need to work out the value of 2 to the power 4. When we have a power 4 like this just means we need to multiply the number 2 by itself 4 times. So it's 2 times 2 times 2 times 2 again. If you do 2 times 2, that's 4, and then if you multiply this by 2, that's 8, and then multiply that by 2, that's 16. So the answer to this question is 16. In the first part of this question, we need to convert 7 kilograms into grams. You should know that 1 kilogram is the same as 1,000 grams. So if that's true, then we want 7 kilograms, we just need to multiply 7 by 1,000. So 7 times 1,000 is 7,000 grams. For the second part of the question, we need to change 450 centimeters into meters. You should know that 1 meter is equal to 100 centimeters. So we don't have 100 centimeters, we have 450. But this time we're going from centimeters into meters. That's the other way. So rather than multiplying by 100, we would divide by 100. So 450 divided by 100 is 4.5. In this question, we've been asked to write down the value of the number 7 in the number 5,721. The digit 7 here is in the hundreds place. This means it represents 700. And that's the answer to the question. In this question, we've been asked to find the next term of the sequence. To do this, we need to work out how you get from one term to the next term. So how would you get from 11 to 8? Well, in this case, you'd subtract 3. And this happens to work with the next terms as well. You subtract 3 to get from 8 to 5, and from 5 to 2. So to get the next term, we just need to do 2 take away 3. So 2 take away 3 is negative 1. For the second part, it says to explain how you got your answer, we can just explain that we subtract 3 each time in this sequence. In the final part of the question, we've been asked to work out the 10th term of the sequence. So we already know what the 5th term is, we just found that one, that's negative 1. So we can just keep going and subtracting 3 until we get to the 10th one. So if we subtract 3, that's negative 4, that's the 6th term, and then subtract 3 again, that's negative 7, that's the 7th term. And then we do it once more, there's the 8th term, negative 10, and the 9th term would be negative 13, and one more time for the 10th term is negative 16. So the answer to this question is negative 16. In this question, we've been given a list of numbers, and first of all, we've been asked to write down a prime number. A prime number is a number that has exactly 2 factors. So the prime numbers begin with 2, because its factors are 1 and 2, 3, its factors are 1 and 3, 5, its factors are 1 and 5, 7, its factors are 1 and 7, and the next one is 11, and they carry on, in fact forever. So which one of these numbers is in our list? It's the number 5. Next we need to write down a square number. To get square numbers, you multiply numbers by themselves. So for instance, 1 times 1, which is 1, means 1 is a square number. 2 times 2, which gives you 4, means 4 is a square number. And 3 times 3 is 9, which means 9 is a square number. And you can actually see that 9 is in our list, so the answer to this question is 9. In part C, we need to write down a multiple of 10. A multiple means a number in that number's times table, so we're looking for any number that's in the 10 times table, and you can see that must be the number 20. For part D, we need to write down a factor of 12. The factors of 12 are the numbers that divide into it. So what goes into 12? Well, we've got 1 and 12, 2 and 6, and 3 and 4. So we're just looking for one of these numbers, and you can see that 6 is in the list, so the answer is 6. And finally, we need to write down the largest odd number. Odd numbers are numbers that are not in the 2 times table. So, for instance, 1, 3, 5, 7, 9, 11, 13, and so on. Now looking at our list, the largest numbers we can see are 24 and 20, but they're both even, because they're in the 2 times table. So the largest odd number we can see in the list is 9. In this question, we've been asked to expand the bracket. To do this, we multiply everything outside the bracket by everything inside the bracket. So if we take the bracket here, we've got 6 multiplied by y first, 6 times y is just 6y, and then we do 6 times negative 2, which is negative 12. So the answer to this question is 6y subtract 12. In this question, we need to work out 3/4 of 80. To find 3/4 of a number, we're first of all going to find 1/4 by dividing by 4. So we do 80 divided by 4, which is 20. Now this is 1/4, but we want 3/4. So we multiply by this 3. 20 times 3 is 60. So when you find a fraction of an amount, you divide by the bottom number and multiply by the top number. So the answer to this question is 60. In this question, we need to complete a table. Let's start with the fraction 3/10. Now when you first learn about numbers, you might be familiar with hundreds, tens, and units. After the units comes a decimal point, and then we move into the tenths. For example, this number here is 100, 5 tens, 6 units, but 2 tenths. Now our fraction is 3 tenths. So there must be a 3 in the tenths column, but we don't need any of the other numbers, so we can just put 0. So to turn 3 tenths into a decimal, we write 0.3. There are no units, but there are 3 tenths. To turn a decimal into a percentage, you just multiply it by 100. So to turn 0.3 into a percentage, we multiply by 100, which gives you 30%. We can use the same process but in reverse to turn 7% back into a decimal. If we multiply by 100 to go from a decimal to a percentage, we must divide by 100 going the other way. 7 divided by 100 is 0.07. Now all we need to do is turn 0.07 back into a fraction. Well, remember earlier we talked about the units column and then the tenths column. The 7 here is sat in the hundredths column. So there are no units, no tenths, but there are 7 hundredths. So we literally write 7 hundredths. And these are the answers to the question. This question is testing order of operations. In the first question here we have an add and also a multiply. You should always do multiplications before you do additions. So we're going to do the 5 times 2 first. So we write the 3 and the plus, and then we work out 5 times 2, which is 10. So this is the same as 3 plus 10, which is 13, which is the answer to the question. In the second part of the question, we've got a subtraction and addition. Now some people might think that you do addition before you do subtraction, especially if they've learnt the phrase BIDMAS, but that's not exactly how it works. Addition and subtraction are just as powerful as each other and should actually be done at the same time. So if you end up with a question that's just got additions and subtractions, you do it from left to right. So we're going to start with 10 take away 5, which is 5, and then we need to add 3 to this. 5 plus 3 is 8, and that's the answer to the question. In this question we've got some simplifying to do. In the first part we've got a multiplied by b multiplied by 8. When you multiply algebraic terms together we don't write the multiply sign, so we're going to remove those, but we also write the numbers before the letters. So the answer to this question is just 8ab. You can see there are no multiplication signs, but also the number 8 is also written at the front. For the second part of the question we need to multiply 5 by p by 4 and by p. Since we need the number at the front, we're going to start by multiplying 5 and 4. 5 times 4 is 20, so this must have a 20 at the front. And then we've got p times p. When you multiply something by itself, we say you're squaring it. So p times p is just p squared. So the answer to this part is 20p squared. In the final part of this question, we're no longer multiplying. Instead, we're adding and subtracting terms together. This is called collecting like terms. So we need to find the terms that are alike. 10x is like negative 2x. So we can simplify those. 10x take away 2x is 8x. Then we look at the y terms. We've got negative 1y plus 4y. To help us work this out, we could consider the calculation negative 1 plus 4. This is easiest done with a number line. So imagine you start at negative 1, which is here, and then you're going to add 4. This means we need to go 4 steps to the right, something like this, 1, 2, 3, 4, and you end up at a positive 3. So negative 1 plus 4 is positive 3, so negative 1y plus 4y must be positive 3y. Now we can't collect the 8x and the 3y together because they're not like terms, so we just write the answer like this. In the first part of this question, we're asked to find the perimeter. The perimeter of a shape is the distance all the way around the outside. So let's pick a point to start on the shape. I'm going to go for this one here, and let's work out the lengths of all of the sides. So this side here first, that's 6 centimeters across, and then we'll go down here, that's 2 centimeters, then across the bottom, that's another 6, and then up the side here, back to the start, that's another 2. So to find the perimeter, I just add up all of these numbers. So 6 plus 2 plus 6 plus 2 gives you 16 centimeters. For the second part of the question, we need to work out the area. The area is the space that the shape is covering. One way to do this is to count up all of those squares. So you've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the answer to the area is 12 centimeters squared. Sometimes you may be given a shape like this and it's not on squares though. To find the area of a rectangle, you could also multiply its length by its width. So 6 times 2, which also gives you 12. In this question, we need to mark some probabilities onto the probability scale. So for the first one, we're looking for the probability that the spinner lands on a letter B. Looking at the spinner, I can see the letter B appears 3 times. So if there are 3 B's and 4 letters altogether, the probability must be 3 for the B's over 4, which is all of the letters. So I need to mark 3/4 onto the line. You can see on the number line we already have 0, 1/2 and 1, but not 3/4. Well, halfway between 0 and 1/2 is 1/4, and halfway between 1/2 and 1 is 3/4. So we need to put the cross at 3/4, which would be here. Now for the second part of the question, we're looking for a letter C. You can see there are no letter C's on this spinner, so the probability must be 0. So we just place a cross at 0. In this question, we need to work out 35% of 140, and we're not allowed to use a calculator. To do this, I would start by finding 10%. To find 10% of any number, you just divide it by 10. So to find 10% of 140, we divide it by 10, which is 14. Now I want to build up to 35%, so if I take another 10%, that's also 14, I've now got 20%. If I take another one, I've now got 30%, so I'm nearly there, I just need 5% more. So let's work out 5%. Well, 5% is half of 10%, so if I half the 14, I get that, which is 7. I can now add up all of these. 10% add 10% add 10% add 5% is 35%, so I need to add 14, 14, 14 and 7. I can do this using column addition, so let's add 4, 4, 4 and 7, which gives you 19, and then add the 1, 1 and 1, and also the little one that we carried to get 4. So the answer to this question is 49. In this question, I need to work out the cost of 32 rulers. You can see from the information given in the question, the price of one ruler is 12 pence. So I need to do 32 multiplied by 12. I'm going to do this using long multiplication. So we write 32 multiplied by 12, and we start with this 2 here and multiply it by the 2 above. 2 times 2 is 4. We then stay with that 2 but multiply it by the 3 above. 2 times 3 is 6. We've now finished with that 2, so we move on to this 1 here. But this 1 isn't really a 1, it's in the tens column, it represents 10, so we have to put a placeholder 0 down as well. Now we multiply this 1 by the 2 above it, 1 times 2 is 2, and then the 1 by the 3 above it, 1 times 3 is 3. All that's left to do now is add up these two numbers. So if we do 4 plus 0, we get 4, 6 plus 2 is 8, and then we have 3. So we end up with 384 pence, which we could write in pounds as £3.84. For the next part of this question, we need to work out how many pens can be bought with £2.16, and you can see the cost of a pen is given in the question at 8 pence. So we just need to divide £2.16 by 8 pence. We'll do all of this question in pence, so 216 pence divided by 8 pence. We start this by doing 8s into 2, which doesn't go, so we pop a 0 down and then carry this 2 to the next number. We then do 8s into 21, which goes 2 times with remainder 5, and then 8s into 56, which goes 7 times. So the answer to this question is we could buy 27 pens. For the next part of this question, we have Annie who's going to buy 10 rulers and 4 pencils, and we can see the cost of a ruler and a pencil is 12p for a ruler and 6p for a pencil. So let's work out the total amount she's going to spend. For the rulers, we need to do 10 times 12 pence, which is 120 pence, and for the pencils, we need to do 4 times 6 pence, which is 24 pence. So if we add those together, we get 144 pence, or £1.44. We're then told that she's going to pay with a £2 coin, and we need to work out how much change she's going to get. To do this, we'll need to subtract £1.44 from £2. So let's take 200 pence, and subtract from that 144 pence. You're going to start on the right hand side with 0 take away 4, which we can't do unless we use negative numbers, so we're going to need to do some borrowing. So if we go all the way across to the 2 on the left, and cross this out, replace it with a 1, and then carry that over. We can also borrow from this 10 here, cross that off, make it a 9, and carry a 1 over. We've now got 10 take away 4 in the right hand column, which is 6, In the middle column, 9 take away 4, which is 5, and on the left column, 1 take away 1 is 0. So we end up with 0.56 or 56 pence. For the first part of this question, we're going to measure the length of the line BC. To do this, we're going to take a ruler, place it next to the line BC, and just read off the value. Now if you have your questions printed, you may get a slightly different answer to me depending on how they were printed. Mine is printed at full size and the answer will be 3.4 centimeters. You may get something slightly different, especially if you're working on a smaller piece of paper. For the second part of this question, we're going to measure the size of the angle marked X. To do this, we're going to need a protractor. We place the centre of the protractor onto the centre of the angle. We also make sure that this baseline of the protractor lines up with one of the lines of the angle, and you can see we've done that. You then need to look at both of the zeros to decide which scale you're going to use. One of the zeros will be on the line and one of them won't. You can see that this zero here is on one of the lines. This zero is on the outside, so we're going to use the outside scale. We then look along the outside scale until we get to the end of our angle, so here, and you can see on the outside scale that comes in at 110 degrees, so the answer to this question is 110 degrees. For the third part of this question, we need to write down a line that's parallel to the line AE. Let's mark on the line AE first, that's this one here. A line that's parallel to this one is a line that will never meet it. So parallel lines are two lines that run alongside each other but never touch. The one that's parallel to this one is the one at the top, CD. For the next part of the question, we're looking for a line that's perpendicular to line AE. When two lines are perpendicular, they meet at a right angle, and you can see we do have a right angle in the bottom left of this shape. So the line that's perpendicular is this one here, AB. So the answer is AB. For the final part of this question, we need to write down the mathematical name for the angle CDE, which is the angle Y at the top of the diagram. Any angle that's more than 180 degrees, like this one, is known as a reflex angle. For the first part of this question, we need to write down the fraction of students whose favourite subject was maths. If we look at the table, you can see there were 10 students who selected maths, and altogether there were 25 students. We're told that right near the start of the question. So the fraction of students whose favourite subject is maths is 10 out of 25. Now the question does also say to give your answer in simplest form. We can simplify this fraction by dividing the top and bottom by some common factors. I can see that 5 goes into 10 and 25. So I'm going to divide the top by 5, but also the bottom by 5. 10 divided by 5 is 2, and 25 divided by 5 is 5. So the fully simplified answer is 2/5. For the next part of the question, we need to write down a ratio this time, and it's the ratio of students who selected maths to those who selected history. So back to the table, we've got 10 for maths, and we've got 8 for history. So as a ratio, this will be 10 to 8. Once again though, we've been asked to give this in simplest form. The number that goes into 10 and 8 is 2, so we can divide both of these by 2. 10 divided by 2 is 5, and 8 divided by 2 is 4. So the simplified answer is 5/4. And for the final part of the question, we need to write a percentage of students whose favourite subject is English. Over to the table, we can see that 6 students selected English. To write something as a percentage, I like to try and write it as a fraction first. So what fraction selected English? Well, that's 6 out of 25. To try and turn this into a percentage, I'm going to try and make the fraction so that it's out of 100. How would I get on the bottom from 25 to 100? Well, that's multiplied by 4. And if I multiply by 4 on the bottom, I'd need to multiply by 4 on the top. 6 times 4 is 24. So 6 over 25 is the same as 24 over 100. But 24 over 100 is 24%. So the answer to this question is 24%. For the first part of this question, we need to write down the city with the lowest temperature. To see which one's the lowest, we can draw a number line. If we mark on all of the temperatures, we've got London, that's at 3 degrees C, Glasgow is -5, Newcastle's -3, and Nottingham is 2. The one that's the lowest temperature is the one that's furthest to the left. That's the -5, which corresponds to Glasgow. For the next part of the question, we need to work out the range of the temperatures. The range is the biggest take away the smallest. So the largest temperature was the 3 for London, and the smallest was that -5 for Glasgow, so we need to do 3 subtract -5. When you subtract a negative number, it's just the same as adding, so we need to do 3 plus 5, which is 8. You can also see the answer to this question visually, because it's the number of steps you need to take to get from -5 to 3. You can see there's 1, 2, 3, 4, 5, 6, 7, 8 steps, so the range is 8. For the final part of the question, we're told the temperature in Glasgow is going to increase by 4 degrees C. You can see the temperature was originally -5, and we need to increase this by 4. So back to the number line, if we start at -5 and then go right 4, 1, 2, 3, 4, you can see the new temperature will be -1. In this question we have a ratio where the recycled material to non-recycled material is 5 to 3, and we need to find the fraction of each bottle that is recycled material. Well, if there are 5 parts recycled and 3 parts not recycled, the total amount of parts is 5 plus 3, which is 8. So if there are 8 parts altogether, and 5 of those are recycled, the fraction that's recycled is 5 over 8, or 5/8. For the first part of this question, we need to find the output if the input is 19. To do this, we just start with 19 and go through the number machine. So if we start with 19, the first thing we come to is a plus 5, so we need to do 19 plus 5, and that's 24. Then for the next part it says divide by 4, so we take this 24 and divide it by 4, which is 6. So the answer to part A is 6. Part B is a little more tricky. We need to find the input and we've been given the output. So we need to do this number machine but in reverse. If we're going to do this in reverse, we need to use the inverse operations. So when we go backwards from the output, rather than dividing by 4, we're going to multiply by 4. And then when we go to the next step, rather than adding 5, we're going to subtract 5. So let's start with the output, which we're told is 1. Then we multiply it by 4, which is 4. And then we take this 4 and subtract 5 from it, and this gives you -1. So the answer to this one is -1. For the first part of this question, we need to write down the mode of the numbers. The mode is the number that's most frequent. You can see that all of the numbers come up just once, apart from the number 3, which comes up twice. So the mode for this question is 3. For the second part of the question, we need to find the median. The median is the middle number when we've put the numbers in order. So let's put them in order first. It would go 2, 3, 3, 7, 11, 16. Then we cross off pairs of numbers, starting with the smallest and the largest. So if we cross off the first pair, then the second pair. Now we can't cross off the next pair or there'll be no numbers left. So we've actually got 2 middle numbers, 3 and 7. If you end up with 2 middle numbers, you want to find the middle of those numbers. Now there's a trick to this. You could add those numbers together, so 3 plus 7, which is 10, and then half this. 10 divided by 2 is 5. So the median for this question is 5. For the final part of this question, we need to find the mean of the numbers. To find the mean, you need to add them all up first of all. So let's do 11 plus 3 plus 16 plus 2 plus 7 plus 3, which gives you 42. And then we divide this by how many numbers there were. You can count 6 numbers, so we need to do 42 divided by 6, which gives you 7. So the mean of these numbers is 7. For this question, we need to draw a bar chart. The first thing to do is look at the frequencies. We need to make sure we draw a frequency scale that goes up to at least 16. So let's pop a 0 at the bottom, and let's check if we can go up in ones. So if we went up in ones, we'd have 1, 2, 3, 4, 5, 6, 7, 8, 9. We're not going to be able to get to 16. Let's go up in twos instead. 2, 4, 6, 8, 10, 12, 14, 16, 18, perfect. So now we can go up to 16. Then what we're going to do is draw a bar for each of the transport methods. So let's start with car, which has a frequency of 16. I'm going to leave a gap first of all, and then draw a bar that has a width of 1 square. And this one's for car, so let's label it car. Now we'll move on to the one for bike, which has a frequency of 4. We must leave a gap in between the bars. So I'm going to leave a gap of 1 square, and then draw the next bar, 1 square wide, up to a height of 4, like this. This one's for bike, so we can label it bike. Now we leave a gap again and move on to bus, which has a frequency of 7. Now we don't have 7 on our scale, but we know it's halfway in between 6 and 8. So we're going to go up to 7, which will be halfway through that square. We label that one bus, and leave a gap and move on to the final one, which is walk, and that has a frequency of 3. So we draw a bar up to 3 and label that one walk. So we're nearly finished. The last thing to do is just label our axes. The vertical axis is frequency, and the horizontal axis is transport method. You'll notice those were both the headings of our table. In this question we're going to solve some equations. The first one is x subtract 4 equals 12. Since we have subtract 4 on the left hand side with the x, we're going to add 4, which is the inverse operation, to both sides. On the left hand side, if you add 4 to a negative 4, they cancel and give you 0. So the negative 4 disappears and we just have x. On the right hand side we've got 12 plus 4, which is 16. We've now solved the equation, so the answer to that one is x equals 16. Moving on to the next one, 3y equals 27. This time on the left hand side it's 3y, which means 3 multiplied by y. The inverse of multiplying is dividing, so we're going to divide both sides by 3. If you divide 3y by 3 you just get 1y, and if you divide 27 by 3 you get 9. So the solution to this one is y equals 9. And on to the final equation, h over 2 equals 10. H over 2 means h divide by 2, so we're going to do the inverse of divide by 2, which is multiply 2 to both sides. On the left hand side this will cancel the 2, so we just have h, and on the right hand side 10 times 2 is 20. So the solution to this one is 20. For this question we need to list all of the possible combinations that Juliet could choose. You can see she has a choice for photo size of small, medium and large, and also a choice of colour, which is full colour or black and white. So for the first combination, let's just pick the first one in each one. That's small for the photo size and full colour for the colour. Then we could also change the colour, so we can keep with small, but change the colour from full colour to black and white. So it'll be small, black and white. Now these are all of the possibilities that have a small photo, so let's move on to the medium photo. So we could have medium photo with full colour, or medium photo with black and white. Now that's the medium ones done, so let's move on to the large photo. We could have large photo with full colour, and large photo in black and white. And they're all of your combinations. For the first part of this question, we need to write down the name of the regular polygon. To do this, let's count how many sides it has. Well, we've got 1, 2, 3, 4, 5, 6. A 6-sided shape is called a hexagon. For the second part of the question, we need to write down the order of rotational symmetry. To find the order of rotational symmetry, it's usually easiest with some tracing paper. So if you take some tracing paper and place it over the shape, and then trace around the shape. You want to make some sort of mark to indicate where you started. I usually put a letter T at the top of the shape. Then we're going to spin the shape around and count how many times it fits perfectly onto itself in one full rotation. So let's begin. We've got 1 time. That's a second. 3 times. 4 times. 5 times. And 6 times. And we know to stop now because that T has arrived back at the top. So the order of rotational symmetry for this shape is 6. For the final part of the question, we need to draw on all of the lines of symmetry. The first one, and perhaps the most obvious one, is straight down the middle here. You could actually do the same thing with all of the other sides. So if we drew a line straight through this side here, and another one straight through this side here, these are all lines of symmetry. There are also some more lines of symmetry though. Rather than going through the sides, we could go through the corners of the shape. So there's a line of symmetry here, there's one here, and there's also one across here. So altogether you need to draw 6 lines of symmetry onto this shape. 3 of them will go through the sides and 3 through the corners. In this question we have a film that starts at 4:12 PM and runs for 1 hour 49 minutes, and we need to work out what time it finishes. So let's start at 4:12 PM. We need to go 1 hour 49 minutes into the future. Let's make this easy and start just by adding 1 hour. If we go 1 hour from 4:12 PM, we end up at 5:12 PM. Next let's add on 40 minutes. If you add on 40 minutes to 5:12, you end up at 5:52 PM. So we've added 1 hour and 40 minutes, there's just 9 minutes left to add. Let's add on 9 minutes. Now you can see we're very close to 6 o'clock here, in fact we're 8 minutes away from 6 o'clock. So if we added 8 minutes it would be 6 o'clock perfectly, but we're adding 9 so there's an extra minute. So this one will be 6:01 PM. We've now added all of the time we need to add, so the answer to this question is 6:01 PM. For the first part of this question we need to write down the coordinates of point A. So let's go over to point A and then read off the values we find at the axes. We always start with the x-axis when we read off coordinates. So if we go from A down to the x-axis here, we see -3, and across we see 2. So the coordinates are at -3, 2. For the second part of the question, we're told that point D is such that ABCD forms a kite. So we need to work out the coordinates of where D is going to be. Well, let's join up the lines we already have between B and C and A and B. So where would we place D to make this a kite? Well, if you look from A to B, there are 4 squares vertically. So if we go 4 squares horizontally across from A, we can find out that D needs to be here. If we join up from C to D now, you can see that we end up with this shape here, which is a kite. It's even easier to see if you turn that kite around. So we just need to write down the coordinates of D. If we go to the point D and read to the axes again, if we go down to the x-axis it's 1, and across to the y-axis it's 2, so the coordinates are 1, 2. For the next part it says write down the coordinates of the midpoint of the line AC. I always find this easier if you actually draw on the line AC. So if we draw that line on here, you can see quite quickly then the midpoint is right here in the middle of the line. That has coordinates 0, -1. Finally, we need to write down the equation of the line L. L is the line on the right hand side that goes through the axis here at 4. To work out the equation of this line, you need to think about which axis it goes through, which is the x-axis, and where it crosses, which is at 4. Any vertical line that goes through the x-axis at 4 has the equation x equals 4. Some people find this a bit confusing because they expect it to be y equals 4 because the y-axis is a vertical line. But it doesn't cross the y-axis, it only crosses the x-axis, and this might be a helpful way to remember. The line y equals 4 would be a horizontal line that goes through the y-axis rather than the x-axis. In this question we've got a pictogram. We need to write down the number of books sold on Monday. Now we've been given a key on the right hand side here. We're told that one of these squares represents 20 books. So the first square here is 20, the second square is also 20, and then we've got half a square, so that must be half of 20, which is 10. So altogether we've got 20 and 20 and 10 books, which makes 50 books in total. So the answer to the first part is 50. For the second part of the question, we're told that 15 more books were sold on Tuesday than on Monday. We're also told the total number of books sold on all of the days was 150, and we need to complete the pictogram. So we've already got Monday done, let's focus on Tuesday. On Tuesday there were 15 more books than on Monday. So if Monday was 50, we need to add 15 to this. So 50 plus 15 is 65. So we need to make sure there are 65 books on Tuesday. So if we start with one square, that's 20. Another square, that's another 20, which makes 40. We can even do another one, that's another 20, which makes 60. Now we want 65, so we only need 5 more books. You can see on Monday that half of a square represented 10. So if we do a quarter of a square, which is half of that, we'll get 5. So we just need 1/4 more of a square. Now if we move on to Wednesday. Remember there were 150 books in total. So let's add up how many books we have so far on Monday and Tuesday. Monday was 50 and Tuesday was 65. If you add these, you get 115. Now if there needs to be 150 in total, I can work out the amount for Wednesday by subtracting this from 150. So 150 take away 115 gives you 35. So we need 35 on Wednesday. Let's start with one square, that's 20. Now if we had another square, that would be 40 and that's too many. So we don't need another square. If we had half a square, that would be another 10, which would put us on 30, which is not quite enough. So we actually need 3/4 of a square this time. So something that looks like this. In this question we have a bag that contains 50 counters and they're red, blue or green. We're told there are 28 red and also that there are twice as many red as blue. We're going to select a counter at random and we need to find the probability that it's green. So the first thing to do here is try and work out how many green counters there are. We know how many red there are, we don't know how many blue there are, nor green. So let's go for blue first, because we are told there are twice as many red as blue. So if there are 28 red, there must be half as many blue. So if we half 28, we get 14. So there are 14 blue counters. Now that we know how many red and blue there are, we can find out how many green there are by subtracting these from the total of 50. So we've got 28 red and 14 blue. That makes a total of 42 for red and blue. And if we take 42 away from 50, we end up with 8 green. The question said what's the probability of selecting a green counter though, so we need to give our answer here as a probability. The safest thing to go for is a fraction. There are 8 green counters and 50 in total, so the probability is 8/50. For this question, we need to use a calculator to work this calculation out, and we're asked to write down all of the figures of our display. So let's take a calculator, and you can see we've got a fraction, so I'm going to start with a fraction button here. On the top I have 1.8, so I type in 1.8, and then it says cubed. So you need to press the x cubed near the top of your calculator here. Then we press the down arrow to move to the bottom of the fraction, and we start with a square root because it says square root 17. And then inside that we have a 17, but the -2 is outside, so we press the right button to get out of the square root and then put subtract 2. And then we press equals and we get this number here. So if we write that number down on our answer line, including all of the digits, remember, as it said in the question, we end up with this number here. For the second part of the question, we need to round this number to 3 significant figures. So let's take the number. The 2 at the front here is what we call the first significant figure. The 7 is the second, and the 4 is the third. And since we need to do 3 significant figures, that means we're going to go up to the 4. Now initially, you may think the answer to this question would simply be 2.74. But just like when we're rounding, we need to check if we round up or not. So if we draw a line after this 4, and then check the next digit, which is this 6 here, a 6 would always tell us to round up. So the 4 will need to round up to a 5, so the answer is 2.75. In this question, we need to do some fraction operations. The first one is a divide. We're going to do 3/5 divided by 9/10. When you divide fractions, you're going to leave the first fraction alone, so 3/5, change the divide to a multiply, and then take the reciprocal of the second fraction. To take the reciprocal of a fraction, you just flip it upside down. So instead of 9/10, it's 10/9. Then we can just multiply them by multiplying the top 2 numbers together and then the bottom 2 numbers together. So 3 times 10, that's 30, and 5 times 9 is 45. We have been asked in this question to give our answer in simplest form though, so we can simplify this fraction. If you take 30 over 45, 15 goes into both of them. So if we divide the top by 15 and the bottom by 15, 30 divided by 15 is 2, and 45 divided by 15 is 3. So the answer to this one is 2/3. For the second part of the question, we need to subtract some fractions. Whenever you add or subtract fractions, you need the same denominator. So if we look at the denominators we do have, that's 3 and 9, we're looking for the lowest common multiple of these, which is actually just 9. So both of these could be written as something over 9. If we look at the first fraction, 2/3, we need to consider how that 3 would become a 9. Well, you'd multiply it by 3. So if you multiply by 3 on the top as well, we do 2 times 3, which is 6. So you can see that 2/3 is the same as 6/9. Now for the second one, it's actually really easy because it's already over 9. It's just 2/9. Now that we have a common denominator, we can just subtract them. If you subtract the numerator, 6 take away 2 is 4, and you keep the denominator the same at 9. So the answer is 4/9. In this question, we need to complete a two-way table. We're going to start by putting all of the information we're given in the question into the table. So the first thing we're told is that they're tracking the arrival time of 40 buses from each of the companies. So the total number of buses for each of the companies must be 40. So we've got 40 total for company A and 40 total for company B. Then we're told that 12 of company A's buses and 7 of company B's buses were late. So in the late column, we're going to put 12 for company A and 7 for company B. Then we have 31 of company B's buses were on time. So in the on-time column for company B, we're going to have 31. And finally, it says 5 buses were early. It doesn't say for which company, so that must be the total. So there were 5 early buses in total, and now we've added in all that information. Now there's still quite a bit to do, but we can work out all of these just using maths. Looking at the right-hand side here, if we do 40 plus 40, we must get the total at the bottom, which is 80. Then if we do the same for the late column, 12 plus 7 gives you 19. Now if we look horizontally at the totals, 5 plus 19 plus the missing one must make a total of 80. So let's add together 19 and 5 first, which gives you 24, and then subtract this from 80, which gives you 56. So the total for on time must be 56. Now we can look horizontally at company B. You can see here we've got a missing number, then plus 31 plus 7 must make 40. So if we add together the on time and late, which is 31 plus 7, that's 38, and subtract this from 40, you get 2. So the early for company B must be 2. And then if we look at the columns here for early, something plus 2 makes 5, So if you do 5 take away 2, you get 3. So there must be 3 early for company A. And if we do the same thing for on time, something plus 31 gives you 56. So if we do 56 take away 31, you get 25. So the on time for company A is 25. There are lots of ways of doing this question. You can do it in any order as long as you end up with exactly this as your answer. In this question, we've been given an exchange rate. We're told that £1 is the same as 1.16 euros. This means that if £1 is 1.16 euros, to go from pounds to euros, we need to multiply by 1.16. But if we're going from euros back to pounds, we would divide by 1.16. Now let's try the question. So Paul is going to change £400 into euros for his holiday. So since we're going from pounds to euros, we're going to multiply that 400 by 1.16. 400 times 1.16 is 464. So £400 is the same as 464 euros. Then whilst on holiday, he spends 319 of those euros, so we better subtract that off. 464 take away 319 is 145. So at the end of the holiday, he'll be left with 145 euros. After his holiday, he's going to convert those euros back into pounds. So to go from euros back to pounds, we divide by 1.16. So we take that 145 and divide it by 1.16, which gives you £125. So the answer to the question, how much money does Paul have left after his holiday but in pounds, is 125. For this question, we need to write down a cube number that's between 100 and 200. Cube numbers are achieved by multiplying a number by itself and then by itself once more. So let's start with 1 times 1 times 1. That's 1. So 1 is a cube number. Then 2 times 2 times 2. That's 8. So 8 is a cube number. Now we're quite far away from 100, but let's keep going. 3 times 3 times 3. That's 27. And then 4 times 4 times 4. That's 64. 5 times 5 times 5 is 125. So we found a number that's a cube number that's between 100 and 200, and that's 125. For this question, we have a square-based pyramid, and we're asked first of all to find the number of faces that it has. Faces are just the surfaces of a shape. So for the surface of this shape, I can see we've got one square on the bottom. We've then got a triangle at the front here, and another triangle at the front here, and then round the back there's also another triangle, and another one. So that was one square face and 4 triangular faces, so that's a total of 5 faces. For the next part, we need to know the number of edges that the shape has. The edges are the lines that are created when 2 faces join together. Usually it's just how many lines you need to draw the shape. So you can see we've got one edge here, another one here, another here, and another here. Then to make the shape 3D, we've got this one, this one, this one, and this one. And altogether, there were 8 lines drawn, so there are 8 edges. Now we'll move on to the vertices. The vertices are just the corners of the shape, the pointy bits. You've got one here, 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 and here. So there are 5 of those, 5 vertices. For the final part of the question, we need to draw on this grid a plan of the shape. A plan is when you view a shape directly from above, so looking in the direction of this arrow here. If we look straight down onto this shape, we would see a square. We can tell the square is 6 centimeters across because that's been labelled. So onto this grid, let's draw a square of side 6 centimeters, something like this. Now when you look down, you wouldn't just see a square, you'd also see all 4 of these lines that join together to make a point at the top. You'd see those as diagonal lines across the square, so something like this, and like this. So this is what our pyramid looks like from the top. I've even got an image here from Google Maps to show you the real pyramids in Egypt, and you can see they do make that shape. In the first part of this question, we need to factorise. This means we need to put it back into brackets. Looking at the 2 terms here, we've got t squared and 6t. Both of them have a t in it, so I can factorise out the t. Now we need to work out what goes inside the brackets. To do this, we think about what we would multiply t by to get to t squared. That's just another t, since t times t is t squared. Then what would we multiply t by to get to 6t? Well, that's just 6. So we put a plus 6 here, and it's now factorised. For the second part of this question, we need to solve an equation. we're going to start by expanding the brackets on the left hand side. So we need to do 5 times x, which is 5x, and then 5 times negative 3, negative 15. And the right hand side is equals 15. The next thing to do is add 15 to both sides. If you add 15 to the left, that'll cancel the 15 that's already there, leaving you with 5x. And on the right hand side, 15 plus 15 is 30. Then we divide both sides by 5. If you divide by 5 on the left, 5x divided by 5 is just 1x, and 30 divided by 5 on the right hand side is 6. So the answer to this question is x equals 6. For part C of this question, we have to solve an inequality. You solve these in exactly the same way as you solve equations, you just need to write this inequality symbol rather than an equal sign. So for this one, where it's 2x is less than 8, we just need to divide by 2 on both sides. If you divide by 2 on the left, 2x divided by 2 is just 1x, and then on the right hand side, 8 divided by 2 is 4, so we put less than 4. You cannot put equals 4 here. So the answer is x is less than 4. For part D of this question, we need to take our answer to part C and represent it on the number line. So we need to represent x is less than 4 on this number line. To do that, we draw a circle at 4, and we don't shade in this circle. If it was less than or equal to, we would shade in this circle. And we want less than 4, so we want all the numbers to the left of this, so we draw an arrow going off to the left like this. For the final part of this question, we've been given an inequality, and we've been told that p is an integer, which just means a whole number. We need to list all of the possible values of p. Well, when you have an inequality that looks like this, it just means all of the numbers in between negative 4 and 2. So let's write those down, negative 4, negative 3, negative 2, negative 1, 0, 1 and 2. However, if we look at this inequality closely, you'll notice on the left hand side it says less than or equal to, but on the right hand side it just says less than. This means we are allowed to be equal to negative 4, but we're not allowed to be equal to 2. So we need to remove 2 from our list. And this is your correct answer. For this question, we need to find the value of x. Here we have the angles around a point. These must add up to 360 degrees. So if we do 360, take away the one we can see, which is 110, we get the answer 250. So the answer is 250 degrees. We need to give a reason for this, and you should say that angles around a point add up to 360 degrees. In this question, we're looking to buy 3 scoops of ice cream. And if you look at the deal, it says that ice cream costs 80p per scoop. So if we do 80p times by 3, we get £2.40. But it also says that we're going to get 15% off if we buy 3 scoops, which we did. So we need to find 15% of this and take it away. To find 10% of £2.40, you can divide it by 10. This is 24p. Then we could find 5% by halving the 10%, half of 24 pence is 12 pence. And then if you add these together, you'll get 15%, which is 36p. So we need to reduce this £2.40 by 36p. So £2.40 take away 36 pence. We'll start on the right hand side and we've got 0 take away 6, but we can't do that without using negative numbers, so we'll go across to this 4. If we cross out the 4 and make it a 3, we can carry one of those 10s over to make a 10 here. 10 take away 6 is 4, 3 take away 3 is 0, then we put the decimal point, and then 2 take away 0 is 2. So the answer to this question is £2 and 4 pence. In this question we have a triangle and a parallelogram, and we're told they have the same area. Since we've got all of the information for the triangle, let's work out the area of the triangle first. To find the area of a triangle, you do 1/2 times the base times the perpendicular height. We can see the base of the triangle here is 12, and its perpendicular height is 10. So we do 1/2 times the base, which is 12, times the perpendicular height, which is 10. Now there's more than one way of doing this, but I like to do 12 times 10 first, which is 120, and then do half of this. So half of 120 is 60. So the area of the triangle is 60 centimeters squared. But we've been told in the question the parallelogram has the same area. Now if we look at the parallelogram, you can see we know the base, that's 15 centimeters, but we don't know its height. That's just called h. To find the area of a parallelogram, you would multiply the base by the perpendicular height, so 15 times by h, whatever it is. So if we did 15 times h, we know we're going to get 60. This means we can find out h by finding what we need to multiply 15 by to get 60. To work this out, we could just do 60 divided by 15, which gives you 4. So the height of this parallelogram must be 4 centimeters. In this question we need to write the fractions in order of size, and we're going to start with the smallest. At the moment it's quite hard to tell which one's the smallest because they have different denominators, so we're going to convert all of them so they have the same denominator. The way we do this is we look at all of the denominators and we find the lowest common multiple, a number that they all go into, and I can see they all go into 20. So we're going to rewrite all of these fractions over 20. If we look at the first fraction, you can see its denominator is 10, but we want it to be 20. So to get from 10 to 20 we multiply by 2. This means we need to multiply 2 on the numerator on the top as well, so 7 times 2 is 14. On the second fraction the denominator is 5, but we want 20, so we need to think about how we get from 5 to 20, which is multiplied by 4. So we multiply the 3 on the top by 4 as well to get 12. Now for the next fraction it's already 20 and we want to get to 20, so it's already done. It must just be 11 over 20. And for the final one, the denominator is 4, but we want to get to 20, so we need to multiply by 5. So we multiply the 3 on the top by 5, which gives you 15. Now that they're all written over the same denominator, it's easy to see which one's the smallest. It's the one with the smallest numerator. So that's 11 out of 20, and we can write that one down first. The next one is 12 out of 20, but in the question that was given as 3/5, so we write 3/5 on the answer line. The next one is 14 out of 20, and that was actually 7/10, and the final one, the biggest one, is 15 out of 20, and that was actually 3/4. In this question we have a circle and we've been told that AB is the diameter and it's 10 centimeters, so let's put this onto our diagram. The first part of the question wants us to find the area of the circle. You can find the area of the circle by doing pi times the radius squared. Now this circle has a diameter of 10 centimeters, which means the radius is half of that at 5 centimeters. So we need to do pi times 5 squared. The question does say to give your answer in terms of pi though, so we don't need a calculator for this question. We just need to know what 5 squared is. 5 squared means 5 times 5, which is 25, so the answer to this question is 25 pi. For the second part of the question we need to find the circumference. To find the circumference you do pi times the diameter. So pi times the diameter, which we know is 10 centimeters, so pi times 10. Once again we need to give this in terms of pi, so pi times 10 is just 10 pi, and that's the answer. In this question we need to do p to the 6 times p to the 3. When you multiply like this you add the indices. So 6 plus 3 is 9. So the answer to the first part is p to the power 9. For the second part we're dividing instead. When you divide you're going to subtract the indices. So we need to do 20 take away 5, which is 15. So the answer is q to the power 15. In this question we need to match each of the diagrams to the parts of the circle. This is something you're just going to need to learn. So they've already done the diameter for us, they've labelled that as E. Next we'll do the tangent. A tangent is a line that touches the outside of the circle, so that's diagram D. Then onto a radius. A radius is a line that goes from the middle of the circle to the outside, so that's diagram C. We'll skip over segment for a moment and go down to a chord. A chord is a line that goes across the circle from one side to the other, and it doesn't necessarily need to go through the middle. So a chord is diagram F. Now we'll go back to that segment. A segment is the area created when you draw a chord onto a circle. So that's the shaded area in diagram A. We call that a segment. And finally the last one must be B. A sector is a shape made by 2 radii and then an arc of the circle. It almost looks like the shape you would cut if you cut a piece of birthday cake. So that sector is B. In this question we have a conversion graph. For the first part we've been asked to change 45 miles into kilometres. To do this we find 45 along the miles axis, which is the one along the bottom, and then we go up from there until we hit the line. We read from the line across to the kilometres axis and read off this number. I've zoomed in this a little bit so you can see what we're looking at. Initially you might think the answer is 71 kilometres, but each square doesn't represent 1. If it did we wouldn't make it up to 80. In fact it goes up in 2s, 72, 74, 76, 78, and then you can see it matches with 80. So the answer to this one is 72 kilometres. For the second part of the question we've got Jim who's going to cycle 300 miles for charity, and we know he's already done 250 kilometres. We need to work out how much he's got left to do, but we need to give the answer in miles. We've got 2 different units in this question, miles and kilometres, and since the answer needs to be in miles, let's change the 250 kilometres into miles. Now you might notice a problem with our conversion graph. It doesn't have 250 kilometers on it, so we need to pick something else to help us convert that instead. I'm going to change 50 kilometers into miles first. So if I go to 50 kilometers and go across and then down, I read that off as 31 miles. So 50 kilometers is the same as 31 miles. Now we don't want 50 kilometers, we want 250. But if I multiply 250 by 5, I do get 250. So we can multiply both sides of this by 5, and we get 250 kilometers is the same as 155 miles. So if we remember what we were doing in this question, Jim needs to cycle 300 miles, and he's done 250 kilometers already, which is the same as 155 miles. So to work out how much he's got left, we do 300 take away 155, which is 145 miles, and that's your answer to the question. In the first part of this question, we need to write down how many Twitter followers Rachel had in 2022. So what we need to do is find the 2022 bar, which is the third one here, and then we look at the key and we can see that Twitter is the part that's shaded in. So if we look at the shaded in part of that graph, read across, and read off that value, you would get 1,300. For the second part of this question, we need to find out how many more Instagram followers Rachel had in 2022 compared to 2021. So we're looking at two different bars this time. If we look at the key, we can see that Instagram is the part of the bar that's shaded with diagonal lines, so the top section on each bar. Let's start with the year 2021. You can see the bottom of the part that we need is at 1,600, but the top of the part that we need is at 2,200. So to find the number of followers for Instagram, we need to do 2,200 take away 1,600, which means there are 600 Instagram followers. Now let's do the same process, but for 2022. The bottom of the bar is at 1,800, and the top is at 2,900. So 2,900 take away 1,800 is 1,100. The question said how many more followers were there in 2022, so if we do 1,100 take away 600, we get the answer 500, which is the answer to this part of the question. For the final part of the question, Rachel says that the number of followers increased each year on all social media networks, and we need to decide if Rachel's correct, and also give a reason. Now if you look at Twitter followers, the bottom part of each bar, you can see that's definitely going up each year. And if you look at Instagram followers, that's also going up each year. But for TikTok, it's not. If you look at the TikTok section of each bar, this one here has 400 people, this one here has 600 people, but this one here has only 500 people. So from 2021 to 2022, TikTok followers actually went down. So the answer is no, as she loses TikTok followers between 2021 and 2022. In this question, we need to draw a stem and leaf diagram. To do this, we're going to look for the smallest and the largest value. This will help us decide our stem. So the smallest value I can see is 59, and the largest value I can see is 92. This tells me my stem needs to go from the 50s to the 90s. So I'm going to put 5, 6, 7, 8, 9 to represent the 50s up to the 90s. Now we're going to need to go through and do each of the leaves. So let's begin with the 50s. There's only one number in the 50s, which is 59. So let's cross that number out and put a 9 onto our diagram. Now we move on to the 60s. I can see a 60, so I'll put a 0 for 60. I can also see a 61, so we need a 1. Then I can see a 63, so let's put a 3. A 64, so let's put a 4. And then two 66s, so I need two 6s. And that's it for the 60s. Then onto the 70s, I can see 70, so I need a 0. I've got another 70, so another 0. A 71. And then we've got two 73, so we need two 3s. I've also got two 77, so two 7s. That's all the 70s, so on to the 80s. We've got an 80, so we need a 0. We've got 81 next, so a 1. 82 next, so a 2. 84, so a 4. And then 88, so an 8. And there's only one number left, which is 92, so in the 90s part of the diagram, we pop a 2. Now we're almost finished, we just need to do the key. You can pick any number from the diagram. I like to pick the first one, so I'm going to write 5, then a line, then a 9, and we're going to write what that is. So that represents 59, and these are percentage scores, so it's 59%. In the second part of the question, we're told that one of the 20 students is chosen at random, and we need to find the probability that this student scored more than 70%. So if we look at the diagram, in the 70s we can have everyone who scored in the 70s apart from the people that scored 70 itself, so we want all of these numbers here. In the 80s we can have everybody, and the same with the 90s. So how many people are represented here? Well, in the 70s there's 5, in the 80s there's 5, and there's one more in the 90s, so that's 5 plus 5 plus 1, which is 11. So there are 11 people that scored more than 70% in the test, there are 20 people altogether, the probability of selecting one of these must be 11 over 20. In this question we need to draw a pie chart of this information. We're going to start by adding up all of these frequencies here. If you add them together you get 24. This means we need to think about splitting the pie chart into 24 equal sections, where each one of those sections represents one of the people. In a pie chart there are 360 degrees, so to work out the size of one of those sections we do 360 divided by 24. This gives you 15 degrees. So every one person represents 15 degrees. Then we multiply all of the frequencies by 15 degrees to work out the size of each of those sectors. So 3 times 15, 7 times 15, and so on. 3 times 15 is 45, 7 15s is 105, 9 15s is 135, and 5 15s is 75. This tells us how big we need to draw each of the sectors for the pie chart. We're going to start by drawing the one for goalkeeper at 45 degrees. To do this, we take a protractor and place it onto the pie chart like this. You'll notice the centre of the protractor is at the bottom of that line, and also the 0 is right at the top of the pie chart, where the line was drawn for us. We're going to read around the outside scale until we get to 45 degrees, we mark a point here, and then join up that point with a line, and that's the first sector. We then do exactly the same thing but put the protractor so the 0 is on the line we just drew, so something like this. You can see the 0 on the outside scale is perfectly on that red line. We then read around for the size of the next one for defender, that's 105 degrees, so that's somewhere here, and then we join that up with a line, and move on to the next one. For the next one we move the 0 to this new red line, and read around the outside to 135 degrees this time, that's about here, and we put a line there. And we don't actually need to draw the final sector, it's already drawn for us. The final thing to do is label this. The first one was goalkeeper, then it was defender, then midfielder, then forward. In the first part of this question we've been asked to work out the real distance between the two towns. And you can see we've been given a scale for this, it says that 1 centimetre represents 4 kilometres. So what we're going to need to do is take a ruler and measure the distance between the two towns on the piece of paper. Now again, it depends how you've had yours printed, but if you had it printed full size on A4, you'll end up with an 8 centimetre line. So the distance on the map between the two towns is 8 centimetres, but we know that each one of those centimetres represents 4 kilometres. So we need to do 8 times 4, which gives you 32. So the distance between the towns is 32 kilometres. For the second part of the question, we've been asked to find the bearing of town B from town A. When it says to find a bearing, we're going to need to measure an angle with a protractor. It's important we know on which town to place this. When it says from town A, that means we're going to place our protractor at town A. So we place the protractor at town A like this. We make sure the centre of the protractor is right on the town, and also that the 0 lines up with the north line. We then read around the outside scale until we're facing town B. You can see that the line crosses the protractor about here, which is at 95 degrees. Now bearings have to be 3 figures, so you can't just write down 95 degrees. If a bearing is less than 100 degrees, you need to put a 0 first. So since this one is 95 degrees, we'll write 095. To start this question, we're going to place all of the information we're told onto the frequency tree. The first thing they tell us here is that 95 of the people were adults and the rest were children. So in the adults box we can write 95. Then we're told that 54 of the adults had popcorn. So after the adults part where it says popcorn we can write 54. And then it says 52 people had no popcorn. Now we can't write this in straight away because it doesn't say whether they're adults or children. What we're going to do next instead is fill in how many children there were. You'll notice there were 95 adults and 200 people altogether, so the remaining people must be children. So if we do 200 take away 95, we get 105. So there are 105 children. We can also work out the number of adults that had no popcorn. Since there were 95 adults altogether, and 54 of them had popcorn, the rest must not have popcorn. So if we do 95 take away 54, we get 41. So 41 adults had no popcorn. Now let's return to that previous statement. It said 52 people had no popcorn. Well, we know that 41 adults had no popcorn, so the rest of the people with no popcorn must be children. So if we do 52 take away 41, we get 11, which is the number of children with no popcorn. Now there's only one more piece to fill in, that's the number of children that had popcorn. There are 105 children altogether and 11 had no popcorn, so if we do 105 take away 11, we find that 94 children had popcorn, and we can now complete the frequency tree. In the second part of the question, one of the 200 people is chosen at random, and we need to find the probability they are an adult who had popcorn. Well, looking at the frequency tree, we can see the number of adults that had popcorn is 54, and the number of people altogether is 200. So the probability of selecting one of these is 54 out of 200. In this question, we need to work out which of the containers has the greatest capacity. It's not immediately obvious because the capacities have been given in different units, one of them's in gallons and one of them's in pints. Fortunately though, we've been told some conversions for gallons, pints and litres. We know that 1 gallon is the same as 4.55 litres. So let's convert the amount in container A from gallons into litres by multiplying by 4.55. So in container A there's 2.5 gallons, or 2.5 times 4.55, which gives you 11.375 litres. So container A contains 11.375 litres, but that still doesn't match with the pints. So let's now convert these litres into pints. To convert litres to pints, it's 1.75, so let's take 11.375 and multiply it by 1.75, which gives you 19.90625 pints. This means that container A has 19.90625 pints, but container B has a little bit more than that at 20 pints. So the answer to the question, which has the greatest capacity, that must be container B. In this question, we need to match one of the boxes to the algebraic words that we've been given. I'm not actually going to do this one in order. I think it's easier to do some before the others. So I'm going to start with the last one, an expression. An algebraic expression will never have an equal sign, so the only one that's an expression here is the last one, 7c minus p. So we can pop that onto this answer line here. Then we're going to move up one and look for an inequality. An inequality will have one of the inequality signs. Less than, greater than, less than or equal to, or greater than or equal to. So that one's quite easy to spot as well. It's the middle one at the bottom. X take away 3 is less than 7. So we can put that answer on the line. Now we're going to jump up to the top one and look for a formula. A formula will usually have many different letters in it, where if you know all of them apart from one, you can work out the value of the missing one by substituting those numbers in. So the one that's a formula in this case is F equals ma. So we can write that on the answer line there. And the last one we're looking for is an identity. An identity is something that is always true for any values. The only one here that's an identity is the one in the top left. It doesn't matter what values you make x, this will always be true. It will be true if x is 1, if x is 5, if x is 10, if x is a million, even if x is negative 2 million. It doesn't matter what value x is, this will always be true. Whereas the other two won't always be true. They'll only be true for certain values of x, and they're equations. So the identity is this one here. In this question, we're told that a can of drink has 330 millilitres, and a bottle of drink has a little bit more at 500 millilitres. Now Sandra is going to buy P cans and Q bottles of the drink, and we need to work out how many millilitres of drink she has. Well, if you bought one can, that would be 330 millilitres. If you bought 2 cans, you do 330 times 2. If you bought 3 cans, you do 330 times 3. 10 cans, 330 times 10. So you're always going to multiply 330 by however many cans you have. Now in this case, the number of cans is p. So we're going to need to do 330 times p, which algebraically is just 330p. Then we do a similar thing for the bottles. Each bottle is 500, but there are q of them. So we do 500 times q, which is 500q. So this tells us how many millilitres we get from the cans and how many millilitres we get from the bottles. In the question we've been asked for the total amount of millilitres, so we just add these together, 330p plus 500q. In this question we need to find the size of angle DBC, that's this angle here. We can't find this angle straight away, we're going to need to find some other angles first to help us get there. We're going to start with this angle DBA, the one I've marked in green. You should notice that this green angle goes with 110 degrees to make angles on a straight line. Angles on a straight line add up to make 180, so if we do 180 take away 110, we find the green angle is 70 degrees, so we can add this onto the diagram. Next we're going to look at the triangle on the left, triangle ABD. That's this one here. We know two of the angles in this triangle, the 70 we just found, but also we have a right angle which is 90 degrees. So we can use that to find the missing angle here which I've marked in blue. If we add together the 90 and the 70, we get 160 degrees, and we know that angles in a triangle add up to 180. So if we take 160 away from 180, we get 20. This means the blue angle, BAD, must be 20 degrees. Now if we look at the whole triangle, you'll notice these lines here which indicate the lines are the same length. A triangle where two lines are the same length is an isosceles triangle. This means the base angles are equal. So where we have a 20 degrees on the left hand side, we also have a 20 degrees on the right hand side. Now we're only one step away from the answer. If we look at this triangle on the right hand side, we know two of the angles, so we can find the missing one, angle DBC, which is the one we're trying to find. If we add together the 110 and the 20, that makes 130, and then if we take this away from 180, we get 50. So the answer to the question is 50 degrees. In this question, we need to work out the value of p when m equals 5. We've also been given this formula p equals 3m plus 30. So what we're going to do is substitute m equals 5 into that formula to work out the corresponding value for p. To do this, we copy out the formula again, but whenever we get to an m, we're just going to write 5. So it's p equals, then it's 3m, but we know that m is 5, so that's 3 lots of 5, plus 30. We can do 3 lots of 5, that's 15, so it's 15 plus 30, and 15 add 30 is 45. So the answer to p for this one is 45. The second part's a little bit trickier, we need to find the value of m when p equals 18. We're still using the same formula, so we're going to copy out that formula again, but whenever we get to p, we're going to write 18. But we're trying to find m this time. So the formula starts with p equals, but we know that p is 18, so it's 18 equals, then it's 3m, but we don't know m, so it's 3m, and plus 30. This is an equation to solve. We're going to start by subtracting 30 from both sides. If you subtract 30 from the left, 18 take 30 is negative 12, and on the right that'll cancel the plus 30 that's there, so we're just left with 3m. Then we can divide both sides by 3, negative 12 divided by 3 is negative 4, and 3m divided by 3 is just 1m. So we end up with negative 4 equals m, which is the same as m equals negative 4. So the answer to the question is negative 4. In this question, we need to construct a line BP that bisects the angle ABC. This is known as an angle bisector. To do this, you're going to need a pair of compasses. So let's take a pair of compasses and place the sharp bit of those on the point B. We're then going to draw an arc that crosses both of the lines BC and BA. So we draw an arc that goes like this. You'll see it crosses those in two places. We have one point here and one point here. Those are going to be important points for the next steps. Now we take the pair of compasses again, but we place the sharp point at each of those points that we just found. So first of all we place the sharp point here, then draw ourselves an arc, and then we place the sharp point on the other cross and draw an arc there. These two arcs will intersect at an important point, which we can call P. If you now draw a straight line with a ruler through P and B, you will have bisected this angle. For the first part of this question, we need to find the area of the trapezium. This is a formula that you should know. The area equals 1/2 brackets a plus b times height. In this formula, a and b represent the two parallel sides of the trapezium and h is the height. So look at our trapezium and let's try and work out what a, b and h are. Well, we can see we've got parallel lines at the top and bottom. We've got the top one going along here. That's a total length of 50 meters since we do 30 plus 20, and also this bottom one here, which is 20. And this leaves the height going from E to D as 30 meters. So we're just going to copy out the formula again, but replace A with 50, B with 20, and H with 30. So we end up with 1/2 brackets 50 plus 20 times by the height, which is 30. Now for this question you could just type this straight into your calculator, since we are allowed a calculator for this one, and it's 1050. For the next part of this question we need to draw on the centimetre grid a scale drawing of the trapezium. And we've been told to use the scale 1 centimetre to 5 metres. This means for every 5 metres on the trapezium diagram we're going to use 1 centimetre on our scale. So the top line from A to B on the trapezium is 50 metres total. Now using a scale of 1 centimetre to 5 metres, we need to divide all of those lengths by 5 to work out how many centimetres for our diagram. So 50 divided by 5 is 10. So we need to draw the length AB as 10 centimetres. So near the top of the diagram I'm going to draw a line that's 10 centimetres long and label it AB. Next I'm going to mark on the point E. E is 20 metres away from B, but remember we need to divide this by 5, since the scale is 1 centimetre to 5 metres, 20 divided by 5 is 4. So this means the point E is 4 centimetres away from B, so it will be here. Directly below the point E, we can find the point D, and it's 30 metres below, and if we divide 30 by 5 we get 6, so we need to go down 6 squares. And this is where the point D is. Then let's try and find the point C. Well, C is 20 metres to the left of point D. We do 20 divided by 5 due to the scale, which gives you 4 centimetres. So we need to go 4 centimetres to the left of D, and we'll find the point C. And then we can just join all of the remaining lines up, and here's your trapezium. In this question, we need to draw the graph with equation y equals 3x plus 2. To do this, we're going to draw a table of values, so something that looks like this. And we're going to label the rows x and y. Now we're actually told the x values in the question. X needs to go from -2 to 3. So -2, -1, 0, 1, 2, and 3. It's the y values that we need to work out. And to do that, we'll use this formula here. Y equals 3x plus 2. This means to get a y value, we do 3 lots of the x value and then add 2. So we're going to do this for each of the x values. I find it's easiest to start with x equals 0. So if x equals 0, y will equal 3 lots of 0 plus 2, which is just 2. So we can put 2 in the table underneath the 0. Now we'll move along to x equals 1. So y will equal 3 lots of 1 plus 2, which is 5. So we can put a 5 underneath the 1. Then we'll move along to 2, so y equals 3 lots of 2 plus 2, which is 8. And we put that into the table. And then on to 3, so y equals 3 lots of 3 plus 2, which is 11. And we put that into the table. Now we can also do the negative ones, so y equals 3 lots of -1 plus 2, which is -1. And also for -2, 3 lots of -2 plus 2, which is -4. And we complete the table. Now you may also find it easier to work out the negative values by looking at the pattern. For a graph like this, it always goes down by the same amount each time, in this case 3. So we take off 3, we take off 3, and then to work out the negative ones, you could just do 2 take away 3, which is -1, and then -1 take away 3, which is -4. As long as you end up with this table, it doesn't really matter. Now we're going to plot the graph. Each of these pairs of x and y values represents a coordinate. So we've got -2, -4 here. So we can plot that on the graph. Then we've got -1, -1, that goes here. Then we've got 0, 2, that goes here. 1, 5 goes here. 2, 8 goes here. And 3, 11 goes here. And you can join those up with a nice straight line. For the second part of this question, we need to decide if the point 25, 77 lies on the line y equals 3x plus 2. So we have a coordinate 25, 77. 25 is our x value. And 77 is our y value. So we just need to substitute 25 into the formula, a bit like we did with the previous values, and see if you get 77 out. So we do y equals 3 lots of 25 plus 2. 3 lots of 25 is 75, and then plus 2 is 77, which is our y value. And this means the point is on the line, so we would say yes. For the first part of this question, we need to find the nth term of the sequence. So let's write out the sequence and find out what it goes up or down in each time. To get from one term to the next in this sequence, you're always going to be adding 3. This means the sequence is a 3n sequence. So we can write 3n onto the answer line. But this sequence isn't exactly 3n. So what we're going to do is write the 3 times table, because it was 3n, above the sequence. So 3, 6, 9, 12, and so on. we need to work out how to get from the 3 times table, which is 3n, to our sequence. And in all cases here, it's plus 5, since 3 plus 5 is 8, 6 plus 5 is 11, 9 plus 5 is 14, and 12 plus 5 is 17. So this sequence has nth term 3n plus 5. For the second part of the question, we need to decide if 98 is a number in the sequence. To do this, we take the nth term, 3n plus 5, and say let's imagine it equals 98. This is just an equation to solve. What we do is take away 5 from both sides. On the left this will give you 3n, and on the right 98 take away 5 is 93. Then we divide both sides by 3. 3n divided by 3 is just 1n, and 93 divided by 3 is 31. Now if at this point you get a whole number, the answer to the question is yes. If you don't get a whole number, the answer is no. So we can say yes for this one, it is the 31st term. For the final part of the question, we've got a different sequence. It has nth term 30 minus 2n, and we need to find the 8th term of it. All we do to find this is replace n with 8. So rather than 30 take away 2 lots of n, it's 30 take away 2 lots of 8. 2 lots of 8 is 16, so we need to do 30 take away 16, which is 14, and the answer to the question. For this question, we need to write 700 as a product of its prime factors, and since this one's non-calculator, we'll do a factor tree. So we start with the number 700, and we need to think of two numbers that multiply to make this. I'm going to go for 100 multiplied by 7. Now if any of these are prime numbers, we're going to circle them. 7 is a prime number, so we'll circle that, but 100 isn't. So we'll continue to split 100. 100 is 10 times 10, and neither of those are prime numbers, so we'll have to split them as well. 10 can be split into 2 times 5, and they're both prime numbers, so we'll circle those. And of course the other 10 is exactly the same, 2 times 5, and they're both prime numbers. So we've now finished the factor tree, so all we need to do is write this as a product. Product means to multiply. So we've got 2, 5, 2, 5, and 7. And we usually write those in ascending order, so lowest to greatest. So we've got 2 times 2 times 5 times 5 times 7. And you may also need to give your answer in index form, and I would always just in case. That means we need to group together any of these numbers that are the same. So we've got 2 times 2 here, which is 2 squared, and also 5 times 5, which is 5 squared. And then we've just got a 7 at the end. So this is your answer to the question, 2 squared times 5 squared times 7. In this question, we need to construct an equilateral triangle of side length 7 centimeters. For an equilateral triangle, all of the sides will be the same length, so we just need a triangle where all of the sides are 7 centimeters. Now you want to construct this, so we're going to use a ruler and compasses only. So take your ruler and draw a 7 centimeter line as the baseline for your triangle. Now remove that ruler. Now take a pair of compasses and place the sharp point at one end, and then open up the pencil so it's 7 centimeters long, which is also the length of this line. You can now draw an arc here, something like this, and then we repeat this from the other side since we also need a 7 centimeter line. So we take the pair of compasses and bring them back, but the other way around, so the sharp point is on the right hand side this time. The pencil is still set to 7 centimeters, which is the length of the red line, and we draw an arc here. This point at the top where the two arcs intersect is an important point. This point is exactly 7 centimeters away from the red line on the left, but also 7 centimeters away from the red line on the right. So if we join the ends of the red line to this point, we know those lines must also both be 7 centimeters. So this is our finished triangle. All of the sides are 7 centimeters in length. Make sure you don't rub out your arcs, it's a bit like you're working out for a diagram question. In this question, we've been asked to estimate this calculation. To do this, we're going to round each of the numbers to one significant figure. So let's begin with the 699. If you rounded that to one significant figure, it would be 700. And then the 32, that would round to 30. And then on the bottom, 19.79 would round to 20. Now that we've done the estimating, we need to do some calculating to see what this will give us. All we do is multiply the top numbers. So 700 times 30. You can do this by doing 7 times 3, which is 21, and then we've got 3 zeros, so 21,000. And then on the bottom is just 20. We need to work out 21,000 divided by 20, but we can simplify this a little bit. If we divide the top and the bottom by 10, on the top if you divide by 10 you get 2,100, and if you divide the 20 on the bottom by 10 you get 2. So this gives us the same answer, 2,100 divided by 2, which is just half of 2,100, which is 1,050, and the answer to the question. For the first part of this question, we've been asked to find how far Sovra lives from the dentist. Now if you look at the top part of the graph here, this must be the furthest distance she's travelled, and if you read that off on the left axis here, you can see that's 20 miles. So Sovra goes to the dentist, then back again, so it must be 20 miles away. For the second part of the question, we need to know how many minutes Sovra's appointment was. The part of the graph that corresponds to Sovra having her appointment is the horizontal section at the top. So this horizontal section starts and ends at these points here. If we look at the times at the bottom, we can see that starts at 10:45 and finishes at 11:30. That must be a total time of 45 minutes. For the final part of this question, we need to work out Sovra's average speed on the journey home. The section which corresponds to the journey home is the last section of the graph after she's finished her appointment. This one here. This section starts here at 11:30 and finishes at 12 when she returns home. The vertical distance here is 20 miles, which corresponds to how far it is from the dentist back to her home. And the horizontal distance at the bottom is the time it takes, so from 11:30 to 12 PM, which is 30 minutes. So Sovra manages to travel 20 miles in 30 minutes. Now how do we turn this into a speed? Well, we need to give the answer to the speed in miles per hour. So if we do 20 miles in 30 minutes, we could double this to say we would do 40 miles in 60 minutes, and 60 minutes is 1 hour. So another way of thinking about this is 40 miles in 1 hour, which is the same as 40 miles per hour. So the answer to the question is 40. For the first part of this question, we need to find the next term in a Fibonacci type sequence. In a Fibonacci sequence, to get the next term, you add together the two previous terms. You can see in the numbers we already have, 2 plus 3 gives you 5. So to find the next term, we need to add together the 3 and the 5, and 3 plus 5 gives you 8. And that's the answer. For the next part, we have a similar thing to do, but it's a geometric sequence now. In a geometric sequence, to get from one term to the next term, you're always going to multiply or divide. So in this one, we need to check, are we multiplying or dividing? Well, to get from 1 to 3, you would multiply by 3. And to get from 3 to 9, you would also multiply by 3. So to get the next term, which is the fourth term, we would need to multiply the 9 by the 3. 9 times 3 is 27. For this part of the question, we're told we have a quadratic sequence, and we need to find the next term again. A quadratic sequence is one where the second difference is constant. So we're going to work out the first differences first. To get from 2 to 5, we're going to add 3. To get from 5 to 10, we add 5, and to get from 10 to 17, we add 7. So these are the first differences, and you can see they're not the same. But now we're going to do the second differences, which is the difference of those differences. So how do we get from 3 to 5? Well, that's plus 2. And how do we get from 5 to 7? That's also plus 2. So the second difference is always going to be plus 2. So what we do is we add 2 to this 7, which gives you plus 9, and then we need to add that 9 to the 17 to get the next term. And 17 plus 9 is 26. In this question, we need to find the size of angle BCE, which is this one here. We're told that line AB is parallel to line EC. This means that ABCE must be a trapezium. When we have a trapezium, we have co-interior angles. So this angle here, the 95, is co-interior to this angle here. This means they add together to make 180. So we can do 180 take away 95, and find the red angle, which is 85 degrees. So we can mark this onto our diagram. Next, we're going to try and find this angle here. This angle must go with the 85 degrees to make 180 since it's a straight line. So if we do 180 take away 85, we get 95. So this pink angle here must be 95 degrees. Next, we're going to try and find the orange angle here, ECD. If we look at the triangle ECD, we can see we've got two of the angles, the 45 and the 95, and we need the third one. And we know these must add up to make 180 since they're in a triangle. So if we do 95 plus 45, that's 140, and then 180 take away 140, we get 40. So the orange angle is 40 degrees. Now we're going to look back at the information given in the question. We've been told that ABCD is a kite. In a kite, there will be one pair of opposite equal angles. So this angle here, the 95 degrees, is the same as the one opposite, this angle over here, which is the orange angle and the blue angle put together. But we know the orange angle, and the blue one is what we're trying to find. So we can just do 95 take away 40, which will give us the blue angle, which is 55 degrees, and the answer to the question. In this question we have Chloe who buys a phone for £120 and then sells it for £138, and we need to calculate Chloe's percentage profit. To work out the profit she makes, we could do £138 take away £120, which is £18. So Chloe makes £18 in profit. But the question didn't want this, it wanted the percentage profit. To do this we use this formula. We do the change, divide by the original, multiplied by 100. When we say the change here, we mean the change in the price. So it went from 120 to 138, which we know is £18. So it's £18, divide by the original amount. Now it originally cost £120, and then we times this by 100. You can put this straight into your calculator and you'll get this as the answer, 15. So 15%. For the first part of this question, we need to work out the density of the cube. We're going to use the formula density equals mass divided by volume. Now we're given the mass in the question, it says it's 60 kilograms, but we're not given the volume. Let's take a closer look at the shape. It says it's a cube, so we know it's 2 meters along the bottom, so it must be 2 meters here, and also 2 meters here, since on a cube all of the sides are the same length. We can now work out the volume of the cube just by multiplying 2 by 2 by 2. 2 times 2 is 4, times by 2 again is 8. So the volume of the cube is 8 meters cubed. So we now have the mass, which is 60 kilograms, and the volume 8 meters cubed. So we can use the formula density equals 60 divided by 8, which gives you the answer of 7.5. For the second part of the question, we need to find the pressure. And good news, we've been given the formula for pressure in the question. It's force divided by area. So do we have the force? Well, we are told the force in the question is 600 newtons, but we don't have the area. When the word area is used in this formula, it's referring to the area of the face that's in contact with the ground. So this bottom face of the cube here. So we need to find the area of that one. That's just 2 times 2, which is 4 meters squared. So we use the formula, which is pressure equals the force, which we're told is 600 newtons, divided by the area, which we just calculated at 4 meters squared. 600 divided by 4 is 150, which is the answer. In this question, we need to convert 8.1 meters squared into centimeters squared. This question looks like it's really straightforward, but actually a lot of people get this question wrong. You probably know that 1 meter is the same as 100 centimeters, so many people would just multiply by 100, which won't work in this question. We're not converting meters to centimeters. We're converting meters squared to centimeters squared, which is different. Let's think about what a meter square actually is. A meter square is a square where it's 1 meter by 1 meter. So this has an area of 1 meter squared. But 1 meter is the same as 100 centimeters, so it's also 100 centimeters times 100 centimeters. Now if I told you to find the area of this, you would do 100 times 100, which is 10,000 centimeters squared. So 1 square meter is actually the same as 10,000 centimeters squared. So rather than multiplying by 100, we need to multiply by 10,000. So 8.1 meters squared is the same as 8.1 times 10,000, which is 81,000 centimeters squared. And that's the answer to the question. In this question, we're going to solve some equations with fractions. So for this first one, we're going to deal with the plus 3. The inverse of plus 3 is subtract 3, so we'll do that to both sides. If you do it on the left-hand side, that'll cancel the 3, so we've just got x over 2. And if you do it on the right-hand side, 8 take away 3 is 5. Then we've got x over 2, which means x divided by 2, so we're going to multiply by 2 on both sides. If you do that on the left, the 2's will cancel, so you've got x, and if you do it on the right, 5 times 2 is 10. So the answer to this equation is x equals 10. Now for the right equation, we need to do things a little bit differently. You might be tempted to try and add 4 first to both sides because you see that minus 4. But actually we need to multiply by 5 first due to the fraction. So we're going to multiply by 5 on both sides. If you multiply by 5 on the left, that'll cancel the 5 that's already there, so you get y take away 4. And multiply by 5 on the right, or 10 times 5 is 50. Now we can add 4. If you add 4 on the left, that'll cancel the 4, so we get y. And if you add 4 on the right, 50 add 4 is 54. So the answer to this question is 54. What's important about these two questions is paying particular attention to the order in which you deal with the numbers. In this question, we've been given the amount of ingredients needed to make 12 pancakes, but we need to work out how much ingredients we'd need to make 30 pancakes. 12 and 30 are both in the 6 times table, so it makes sense to first of all work out how much of each ingredient we need to make 6 pancakes instead. To get from 12 pancakes to 6 pancakes, you would divide by 2. So let's list all of the ingredients we need to get 6 pancakes by dividing all of the ingredients by 2. If we divide flour by 2, we get 150 grams. If we divide the 400 milliliters of milk by 2, that's 200 milliliters. And if you halve 2 eggs, you get 1 egg. So this is the amount of ingredients we'd need to make 6 pancakes. Now we can get from 6 pancakes to 30 pancakes by multiplying by 5. So if we multiply each of the ingredients by 5, we'll get our answers to the question. So 150 times 5 is 750, 200 times 5 is 1000, and 1 egg times 5 is 5 eggs. So the answers to the question are 750 grams of flour, 1000 milliliters of milk, and 5 eggs. In this question, we've been given a ratio, 3 to 5 to 4, which is the number of red, green, and blue counters in a bag. So we can write the ratio, red to green to blue, is 3 to 5 to 4. Then we've been told in the question there are 36 blue counters, so we can write this underneath the blue column. Now we compare the number of parts for blue, which is 4, to the number of counters for blue, which is 36, and think what would we multiply 4 by to get to 36? Well, you can work this out by doing 36 divided by 4, which is 9. So 4 times 9 is 36. This means we need to multiply all of the numbers in the ratio by 9. 3 times 9 is 27, and 5 times 9 is 45. This means in the bag we've got 27 red counters, 45 green counters, and of course we already knew 36 blue counters. The question says how many counters are in the bag in total, so we can just add up all of those numbers, and if you add up all of those numbers, you get 108. In this question, we're trying to find out which of the jars of jam represents the best value for money. If we're trying to find the best value for money, we're going to use the formula, the price in pence, divide by the amount. We'll do this for the small jar first. So what's the price in pence of the small jar? Well, that's 65 pence. And what's the amount? Well, that's just how much jam we get, which is 250 grams. So we do 65 divided by 250. If you use your calculator for this, you'll get the answer 0.26. Now we're going to do the same process, but for the large one. So what's the price in pence? That's 120 pence. Divide by the amount of jam we get, which is 450 grams. This time we get the answer 0.266666. It's actually 6 recurring. These 6s go on forever. What these numbers tell us is the price of just 1 gram of jam from each of those jars. So for 1 gram of jam from the small jar, it's 0.26 pence, and for 1 gram of jam from the other jar, it's 0.266666, and so on pence. So the one that's better value for money will be the lower number, which is the first one up here, 0.26. So the smaller jar is actually better value. For the first part of this question, we need to find the number of triangular tiles in pattern n. This just means we need to find the nth term for the number of triangles. So let's first of all write down how many triangles there are in each of the patterns. In the first pattern I count 6 triangles, in the next pattern I count 8, and the next pattern I count 10. So it looks like it's going up by 2 each time. So if it goes up by 2 each time, we know this is a 2n sequence. So the nth term must start with 2n. But this sequence isn't exactly 2n, that's just the 2 times table. So let's write the 2 times table above the sequence like this, 2, 4, 6, and think about how we would get from the 2 times table to our sequence, the number of triangles. Well, in all cases here, it's plus 4. 2 plus 4 is 6, 4 plus 4 is 8, 6 plus 4 is 10, and so on. So the answer to this question is 2n plus 4. In the second part of the question, we're told that Rich is going to make a pattern, and he's going to use 88 of the tiles in total, so that's squares and triangles. We need to work out how many square tiles he's going to use. First of all, we're going to write down the number of tiles in each of the patterns, that's squares and triangles. So in the first pattern, there's 8 tiles total. There are 6 triangles and 2 squares. In the next pattern, there's 12, that's 8 triangles and 4 squares, and in the next pattern there are 16. There's 10 triangles and 6 squares. So we want to try and find the nth term of this sequence. We'll do it in the same way as the one we did before. This sequence goes up by 4s each time, so it's going to be a 4n sequence. So we write the 4 times table above the sequence, 4, 8, 12 and so on. Then we work out how we get from 4n to our sequence, and this one's plus 4. So the nth term for the total number of tiles, which is squares and triangles, is 4n plus 4. Now we know that Rich is going to use 88 of those tiles, so we want to find out when 4n plus 4 equals 88. This will tell us which pattern he's creating. If you take away 4 from both sides, on the left the negative 4 will cancel with the positive 4, so we just have 4n left, and on the right 88 take away 4 is 84. We can then divide both sides by 4, 4n divided by 4 is 1n, and 84 divided by 4 is 21. So we end up with n equals 21, which means Rich is going to make pattern number 21. Now we need to work out how many squares it will have. Well, let's look at how many squares each of the patterns have. The first pattern has 2 squares. The second pattern has 4 squares. The third pattern has 6 squares. So the number of squares is always just double the number of the pattern. If it's pattern 1, it's 2, pattern 2, it's 4, 3, 6. If it were pattern 10, it will be double 10, which is 20. But it's not, we've got pattern number 21, so we need to double 21, which is 42 square tiles. In this question we have Peter and Wendy, and they're both going to run a 400-meter race. Peter runs at an average speed of 8 meters per second, but Wendy runs a little bit slower, an average speed of 6.25 meters per second. And we know that Peter wins the race, presumably because he's going faster. After Peter finishes, we want to work out how many more seconds it will be before Wendy finishes. So what we need to do is work out how long each of them takes to do the race. Let's start with Peter. We're going to need to use the formula time equals distance divided by speed. The distance is 400 meters for both of them, but they have different speeds. So for Peter, the distance is 400 meters, but his speed is 8. So we need to do 400 divided by 8, which gives you 50 seconds. We do the same calculation for Wendy, but instead of 8, we do 400 divided by her speed, which is 6.25. This gives you 64 seconds. So if Peter takes 50 seconds and Wendy takes 64, we can just subtract those. 64 take 50 gives you 14 seconds, which is the answer to the question. For the first part of this question, we need to work out the modal number of goals. The modal is just another way of writing the mode. The mode is the most frequent number, so we want to know the most frequent number of goals from these matches. If we look down the frequency column, we can see the highest number here is 6. This means we scored 1 goal in 6 matches. So 1 actually came up the most, therefore the answer to the question is 1. Next we need to work out the median number of goals. The median is the number that's in the middle when we put them in order. So you need to imagine we line up all of these amounts of goals and find the middle one. Now there is a quick way of doing this. We take the number of matches, which we know in the question was 19. We add 1 to this, so 19 plus 1 is 20, and then divide this by 2, which gives you 10. This tells us that of the 19 matches, the one that's in the middle is the 10th match. So what we're going to do is go down the frequency column until we've counted up 10 matches. So if we go down the frequency column, for 0 goals we've got 2 matches, so it's not that. Remember, we're trying to get to the 10th match. Then if we add in the next matches where we score 1 goal, there's 6 of those, that makes a total of 8 matches. It's not that one. And if we add in the next 4 matches, that brings us up to 12 matches. So we've now gone past the 10th match in order, so we know we found the median. So the median number of goals is actually 2, so the answer is 2 goals. For the final part of this question, we need to find the mean number of goals. To do this, we need to work out the total number of goals scored in all of the matches and divide it by how many matches there are. We're going to look at the table. In the first part of the table, it says 0 goals were scored 2 times. Now if you think about it, in 2 matches you scored no goals, that's a total of 0 goals. Then if we look at the next bit, we scored 1 goal 6 times. This is a total of 6 goals because 1 times 6 is 6. Then we scored 2 goals in 4 of those matches, so 2 times 4, that's 8 goals. Then we scored 3 goals 4 times, that's 12 goals, 3 times 4 is 12, and we scored 4 goals 3 times, again 4 times 3 is 12. So if we add up all of these numbers, we end up with our total number of goals, which is 38. Now we need to know how many matches we played. Well, we were told that in the question, or you could add up the frequency column, and this will give you 19. Now to find the mean number of goals, you do the number of goals divided by the number of matches, so 38 divided by 19, which is 2. So the answer to this question is 2. For the first part of this question, we need to work out which of the points is considered an outlier. An outlier is one of the points that doesn't fit with the general trend of the rest of them. So the outlier in this question is this point here. We need to write down its coordinates. So if we go down to the x-axis, you can see the age is 32 years, and if you go horizontally across to the y-axis, you can see the reaction time is 620. For the second part of the question, we need to write down the type of correlation shown. When the points are going in an upward direction, like in this diagram, we say that's got a positive correlation. For the final part of the question, we have a person who is aged 55 and their reaction time is measured. We need to use the graph to estimate their reaction time. To do this, we're going to draw a line of best fit. A line of best fit will go in the general direction of the points. Now everyone will draw a slightly different line of best fit, but a good rule of thumb is to try and keep roughly the same amount of points above and below the line. So here's an example of what might be a suitable line of best fit. You can see I've got roughly the same amount of points above the line as I do below the line, and it also follows the general direction of the points, going upwards. Then we go to the age axis and find 55, which is halfway in between 50 and 60. We go up until we hit our line of best fit, and then across and read off the reaction time. So I get a reaction time here of about 560 milliseconds. Now depending on the way you drew your line of best fit, you may get a slightly different answer. For the first part of this question, we need to describe the single transformation that maps triangle A onto triangle B. Looking at the two triangles here, A and B, I can see they look exactly the same. One of them has just been moved to get the other one. When we move a shape, we call it a translation. Now we need to think carefully about how we can describe this exact translation. To do this, let's shade in triangle A and think about how we could get it to triangle B. Well, to get from A to B, you're going to move the shape 1 square to the right, 2 squares to the right, 3 squares to the right, and then it lands on shape B. To describe translations, we use a vector. So we would say it's a translation by the vector, and then we draw a vector, and we need to put some numbers in. The top number tells you how far you go left or right, and the bottom number tells you how far you go up or down. Now we didn't go up or down at all, but we did go to the right. We went to the right 3 squares. So we put a 3 on the top, and to signify that we don't go up or down at all, we put a 0 on the bottom. For the second part of this question, we need to rotate triangle A 90 degrees anti-clockwise about the point 1, 0. To do this, we're going to take a piece of tracing paper and put it over the graph. Then we're going to draw over shape A like this, and then we mark on the coordinates of the point given in the question. That's the point 1, 0, so that's here. Then what we would do is place our pen onto the point we've just marked with a cross and turn the tracing paper 90 degrees anti-clockwise. 90 degrees anti-clockwise is 1/4 of a turn to the left. So we turn the tracing paper like this, and you can see where the new shape needs to go. So you take off your tracing paper and draw that shape onto the graph, and in the question it says can we label this triangle C, so let's do that as well. For the first part of this question, we also need to describe a transformation. This time it's rectangle A onto rectangle B. It should be fairly obvious from looking at these two rectangles that they have changed size, so we call this an enlargement. We need to give 2 more bits of information when we describe an enlargement. The next piece of information we give is called a scale factor. This tells us how much we've enlarged the shape by. So if we look at the width of shape A, we can see it's 2 squares, and then the width of shape B is 4 squares. So this has got twice as big, so we say the scale factor is 2. Finally, we need to find the center of enlargement. To do this, we're going to pick corresponding points on shape A and B and join them with straight lines. So I'm going to pick the top right corner of shape B and also the top right corner of shape A. I'm going to draw a straight line through these points. We do this with another pair of points, so I'm going to go for the bottom left corner this time, bottom left of B and bottom left of A, and then join those up with a straight line. You can see that both of these lines cross at a special point. That's this point here. We call that the center of enlargement, and we need to write its coordinates. So to complete the description here, we'd say with center 1, -4, which was the coordinates of that point. For the final part of this question, we need to reflect rectangle A in the line y = 1. The line y = 1 is a horizontal line that goes through the y-axis at the point 1. So it's a horizontal line that looks like this. We need to reflect shape A in that red line. To do this, we're going to see how far the shape is to the line and then continue this distance past the line. So if we take the points here, that's 1 square to the line, 2 squares to the line. This means we need to go 2 more squares past the line to find out where these points would map to. So if we go 1 square, 2 squares, those points would map here. If we did the same with the points at the bottom of shape A, they would be 3 squares away, so they'd need to go 3 squares past the line. So the reflected shape will end up here. We need to label this new rectangle C, and then that's the question finished. In this question, we need to compare the distribution of heights for Year 7 and Year 11. To do this, we're going to make 2 comparisons. One comparison for the mean and one comparison for the range. Let's start with a comparison for the mean. If we look at the data in the table, we can see the mean for Year 7 is 144, but for Year 11 it's 173. So first of all, we're just going to state which one of them is higher. So I would say Year 11 have a higher mean. Then we're going to write a sentence that explains what this tells us, in the context of the question. It's really important that you include the context in this question to get the marks at this point. So we need to mention that this is about heights. So what does it mean if you have a higher mean? Well, this tells us that Year 11 are taller on average, and those words on average are particularly important in this question. It doesn't mean that every Year 11 is taller than every Year 7, it just means the average student is taller in Year 11 than they are in Year 7. Now we're going to move on to the range. So the ranges are 25 for Year 7 and 40 for Year 11. So again, we're just going to write which of them is higher. So Year 11 have a higher range, and then we're going to explain what that means in the context of the question. So we need to talk about heights. Well, what does it mean if you have a higher range? It means your heights are more varied. So to finish this sentence, we would say, so their heights are more varied. In this question, we're told to work out the size of angle ABC, which is the missing one here. We're told that this shape is a hexagon. It has 6 sides. We can use this information to work out the sum of all of the angles in the shape. We would use the formula interior angle sum equals the number of sides take away 2 times by 180. So if this has 6 sides, we need to do 6 take away 2 times 180, which is 4 times 180, which is 720. This tells us that all of the angles on the inside of that shape must add up to 720. So we know all of the angles apart from 1, so we can add all of those up. So if we added 95, 120, 110, 100, and 145, we end up with 570, and then we could subtract this from 720. So 720 take away 570 is 150. So the missing angle ABC is 150 degrees. For this question, we need to find the highest common factor of 75 and 210. We're going to use prime factorisation to help us with this. Now, since we're allowed to use a calculator for this question, I'm going to show you how to use a calculator to prime factorise these numbers. I'll show you with 75 as an example. So take the calculator and then type in 75, and then press equals. And it'll just tell you 75, which doesn't seem too useful until you press shift, and then we come along to this button here that looks like it's got loads of commas on it, but it says fact above it. And when we press that number, it will show us the prime factorisation. So 75 is 3 times by 5 squared. So let's write that down. 75 equals 3 times 5 squared, which is the same as 3 times 5 times 5. Now if you do the same thing on your calculator for 210, you press 210, then press equals, then press shift, then fact, it will show you that 210 is the same as 2 times 3 times 5 times 7. Now, what we're going to do next is draw a Venn diagram, one of the circles for 75 and one of the circles for 210. We're going to look for any numbers that are in both of the prime factorizations. You can see we've got a 3 in both of them, so I'm going to cross that out and place it in the middle. And there's also a 5 in both of them, so I'll cross out one 5 from each of them and place that in the middle. I've got no more pairs of numbers that I can cross out because in the 75 I've just got one 5 left, and in the 210 I've got a 2 and a 7. So those go in the outside bits of the circle. We put a 5 in the 75, and then we put the 2 and the 7 in the 210. Now why is this helpful for the highest common factor? Well, if you've done this correctly, the numbers that are in the middle section here will multiply together to give you the highest common factor. So you just need to do 3 times 5, which is 15, and that's the answer to the question. Now this Venn diagram can also find us the lowest common multiple. To find the lowest common multiple, you take the same Venn diagram, but you multiply all of the numbers in the diagram. So we need to do 5 times 3 times 5 times 2 times 7. Use your calculator for this, and it will tell you 1050, which is the answer to the question. In this question, we've got Harry who's taking penalties, and we've been asked to find which of the days gives the best results of the probability that Harry will score a penalty. So if we look at each of the days in turn, on Monday he scored 19 and he missed 11. That means he took a total of 30 penalties. On Tuesday it was 35 and 25, if you add those together you get 60 penalties. On Wednesday 27 and 18 makes 45 penalties. This means that Tuesday gives the best estimate for the probability since he took most penalties on that day. The more times you do something, the more accurate the results will be. So, we could write the answer as Tuesday, as most penalties were taken. In the second part of this question, we've got Ella, and the probability that she scores a penalty is 0.7, and she's going to take 200 penalties, and we need to work out an estimate for how many she's going to score. In order to work this out, all we need to do is multiply the number of penalties she's taking by the probability she scores, so 200 times 0.7. Which will give you 140 scores. In this question, we need to show that 4.5 divided by 1 3/4 is equal to 2 4/7. We're going to start this by looking at the fractions on the left-hand side and converting those to improper fractions. To do this, we would multiply the 4 by the 2 and then add the 1. So 4 times 2 is 8, and add 1 to that is 9. This means that 4.5 can be written as 9 over 2. We keep the bottom number the same. Now let's do the same with the next mixed number. We do 1 times 4, which is 4, and then add 3, which is 7. So this one is 7 over 4. So the question could be rewritten as 9 over 2 divided by 7 over 4. When we divide fractions, remember from earlier, we keep the 9 over 2 the same, we change the divide to a multiply, and then we take the reciprocal of the second fraction, which means turning it upside down. So instead of 7 over 4, 4 over 7. Now we can just multiply 9 times 4, that's 36, and 2 times 7, that's 14. We need to show that this is equal to 2 4/7. First of all, we can simplify. If you divide both of these numbers by 2, well, half of 36 is 18, and half of 14 is 7. We're nearly there now. How many 7s go into 18? Well, that's 2. And how many would be left over? Well, 2 times 7 is 14, so to get to 18 there's 4 left over, and we keep the bottom number the same. So it's 2 4/7, which we needed to show in the question. In this question we have a pie chart, and we're told that Craig spends 96 minutes revising for chemistry, and we need to work out how long he spends revising for physics. I notice first of all that we're missing the angle for physics, so we'll try and work that out first. We know the angle for biology is a right angle, so that's 90 degrees. We know the full angles in the pie chart needs to make 360. So if we add the 160 and the 90 that we have, this makes 250, and subtract this from 360, gives you 110. So the angle for physics is 110 degrees. Now we know how long he spends revising chemistry, that's 96 minutes, we're told that in the question. So the 160 degree sector here is equal to 96 minutes. We just need to know how many minutes 110 degrees is worth. I notice that 160 and 110 are both multiples of 10. So instead I'm going to work out how many minutes 10 degrees is worth. To get from 160 to 10 degrees, I would divide by 16. So if I do 96 divided by 16 on my calculator, I get 6. This means every 10 degrees is worth 6 minutes. Well, how many 10 degrees would I need to get to 110 degrees? Well, 10 times 11 is 110, so I can multiply the 6 by 11 as well. 6 times 11 is 66 minutes. This means that a sector of size 110 degrees represents 66 minutes, just like physics, so that's the answer to the question. In this question, we're told that a floor of area 10 square meters can be tiled by 3 workers in 8 hours. We need to work out how long it's going to take to do a bigger floor, that's 25 square meters, and we've got more workers, 4 workers. Let's forget about the 25 square meters for a second and just think about the 10 square meters. We were told that 3 workers could do this in 8 hours. This means the total amount of work that was done by those workers is 3 times 8, which is 24 worker hours. Now if we sent 4 workers to do the same job, 10 square meters, how long would they take? Well, since we've got 24 worker hours and 4 workers to do the job, we could do 24 divided by 4, which gives you 6. So if 4 workers were to do 10 square meters, they would take 6 hours. But the new floor isn't 10 square meters, it's 25 square meters. We need to think about how many times bigger this floor is. We can do that by doing 25 divided by 10, which is 2.5. So the floor is 2.5 times bigger. This will mean it will take 2.5 times longer. We know that 4 workers will take 6 hours to do 10 square meters, so we can take this 6 hours and multiply it by 2.5, which gives you 15. So the answer to this question is 15 hours. In this question we have Connor, who's got £500 to invest for 3 years at 4% interest. In the first part of the question we're going to imagine the interest is simple interest. So if it's simple interest, we just need to work out 4% of the £500. To do this, I'm going to work out 1% first. To work out 1% of 500, I divide it by 100, which is just £5. And if that's 1%, to get 4%, I need to multiply this £5 by 4. 5 times 4 is 20, so £20 is 4%. This means the interest is £20, but he's going to invest it for 3 years, so we're going to get £20 interest every single one of those 3 years. So if we do £20 times 3, we get £60. So he's going to gain £60 in interest. If he puts £500 into the bank and he gains £60, just do 500 plus 60, which is £560. Now in the second part of this question, we're using the same numbers, but we're assuming it's compound interest now. This is slightly different. We first of all need to work out the multiplier for a 4% increase. To do this, you do 100% plus 4%, which is 104%, and then divide 104 by 100, which is 1.04. This means to increase any number by 4%, we're going to multiply it by 1.04. Now he's going to invest £500 in this bank, and in the first year it's going to increase by 4%, so we multiply it by 1.04. But we'd also multiply this by 1.04 after the first year, and then once more again after the second year. So we need to multiply it by 1.04 3 times for the 3 years. So we raise this to the power 3. If you type this exactly as it is here into your calculator, you'll get this number. Now we need to round this to a sensible amount since it's money, so 2 decimal places. So your answer needs to be £562.43. For this question we want to work out the value of x, which is the angle EAG. We're going to use the formula interior angle sum that we used in a previous question. We want to work out the interior angle sum of the 5-sided shape on the outside. So we do 5, the number of sides, take away 2, times 180. This will give you 540. This means all of the angles inside the 5-sided shape add up to 540 degrees. Now we're also told it's a regular pentagon. So pentagon means it's 5 sides, but regular means that all of the angles on the inside are the same size. So we can take this 540 and divide it by 5. This means that all of the interior angles are 108 degrees. So we can mark on the angle EAB as 108 degrees. That's this blue one here. Now we're told in the question that ABFG is a square. That means that this angle here is a right angle, 90 degrees. So if we look carefully at this, we can work out the angle x by subtracting that right angle from 108. So if we do 108 take away 90, we find that x is 18 degrees, which is the answer to the question. For the first part of this question, we need to find the reciprocal of 1.25. To find the reciprocal of any number, you just need to do 1 over that number. So we need to do 1 over 1.25. This is just the same as 1 divided by 1.25, which if you type into your calculator, it will give you the answer, which is 0.8. For the second part of the question, we need to write down an error interval. To do this, we're going to draw a little number line, and we're going to place the number from the question, which is 6.4, in the centre of that number line. Now this error interval is for a number that's been rounded to 1 decimal place. So we need to think of the number that's 1 decimal place below 6.4 and above 6.4. So the 1 decimal place number below 6.4 is 6.3, and the one above is 6.5. Now the error interval consists of the numbers in the highlighted section here. This is halfway in between 6.3 and 6.4, and 6.4 and 6.5. So what's halfway between 6.3 and 6.4? That's 6.35, and what's halfway between 6.4 and 6.5? That's 6.45. These form the lower bound and the upper bound of your error interval, so we can just put those onto the answer line. We do 6.35 is less than or equal to n is less than 6.45. For this question, we need to draw a frequency polygon. Whenever you draw a frequency polygon, you need to work out the midpoints of the groups you've been given. So let's do that first. For the first group, from 60 to 70, the midpoint is 65, then from 70 to 80, it's 75, and then it goes 85, 95, 105. Now we need to plot the points. We're going to plot a point at the midpoint of each group with its frequency. So for the first one, it's 65 with 3. So we go along to 65 on the bottom axis where it says time, and we go up to a frequency of 3. So the first cross would go here. And then for the next one, it's 75 with 12. So we go along the bottom to find 75, and then go up to 12. And then it's 85 with 15, that one would go here. 95 with 44, that one goes here. And then finally 105 with 26, and that one goes here. To finish a frequency polygon, you just need to draw straight lines between each of the points, so something that looks like this. For the first part of this question, we're looking to find the modal class. This is just the group with the highest frequency. So if we look at the frequencies, we can see the highest one of those is 28. And then if we look across to the times, that's for a time between 10 and 20 seconds. So we just copy down what it says in the table there. 10 is less than t is less than or equal to 20. For the second part of the question, we're looking for the interval that contains the median. The median is the middle number when in order. This is really similar to a previous question we did. We take the number of students, which is 60, then we add 1 to this, which is 61, and then divide this by 2, which gives you 30.5. So we're looking for the 30.5th person. Now that's obviously not a real person, but we can still find where that would be in the table. So what we do is we go down the table in order, taking each group in turn, until we hit 30.5. So the first group here has 28 people in it, and then if I added in all of the people from the next group as well, that's another 13, I'd get to 41. And I've clearly just gone past the 30.5th person. So the median must be in this group here. So on the answer line we write 20 is less than t is less than or equal to 30. And for the final part of the question, we need to find the mean time spent revising. I'm going to bring in another copy of the table for this one. What we're going to need to do is multiply the time by the frequency. But at the moment, the time is a group of numbers from 10 to 20, 20 to 30, and so on. So we're going to replace each of those with the midpoint of each group. So for the first group from 10 to 20, the midpoint of that group is 15. And then the next group is 25, and then 35 and 45. So we're going to multiply these midpoints by the frequencies. So we start with 15 times 28, which is 420, 25 times 13, 325, and then 35 times 13, 455, and finally 45 times 6, 270. We then add up all of these. So if you add up all of this final column, you end up with 1,470. This represents an estimate for the total amount of time that all students spent revising. But if we want to work out the mean time spent revising, we need to divide that by how many students there were. You can get this by adding up the frequency column, which is 60, but we were also told that in the question. Now all you need to do is 1,470 divided by 60, and you end up with the answer 24.5. So the answer to this question is 24.5 minutes. For the first part of this question, we need to complete the table. You can see we've been given all of the x values, but we're missing some of the y values. To work out those y values, we're going to substitute each of the x values into this equation up here. This will give us the y values. To do that, we're going to start with x equals 2. We're going to copy it out again, but wherever there's an x, we're going to write a negative 2. But whenever there's a negative number, you should definitely put that number in brackets. This one is also a very common calculator paper question, so you can just type this straight into your calculator. So for the first one, we've got x is negative 2, and we're going to do x squared minus 3x minus 1. So let's start with x squared, which we know is negative 2 squared, then subtract 3 lots of negative 2, then subtract 1. If you type this into your calculator or work it out, you'll end up with 9. So when x equals negative 2, y equals 9. Now they've already done negative 1 for us, so let's skip on to 0. So we need to do 0 squared, subtract 3 lots of 0, subtract 1. And this is negative 1. So when x is 0, y is negative 1. We also need to do it for when x equals 1, so 1 squared, take away 3 lots of 1, take away another 1, which is negative 3. And finally, we also need to do it for 4, so 4 squared, take away 3 lots of 4, take away 1, which gives you 3. So when x is 4, y is 3. Now for the second part, we need to draw the graph, but we can use the table to help us do this. Each of those pairs of x and y values is a coordinate, so let's start with this first one, negative 2, 9. If we were to plot x at negative 2 and y at 9, that would go here. Then we move on to negative 1, 3, that goes here. 0, negative 1 goes here. 1, negative 3, 2, negative 3, 3, -1, and 4, 3. Once you've plotted all of the points, you can see the shape of the graph. This one isn't a straight line. It's a quadratic graph, so it makes a characteristic U shape. So if we join it up, we need to do it with a smooth curve, not straight line, something that looks like this. And for part C of the question, we need to estimate the solutions to an equation. Now if you look at the equation we've been given, and then look at the equation of the graph we've drawn, you'll see they match. Whenever you're solving an equation equal to 0, that's when the graph crosses the x-axis, so we're just looking for the x values for where the graph crosses the axis. You can see it crosses in two places, once here, and once here. So we just write down those x values. For the first one, it crosses at about x equals -0.3. Now you will get some slight flexibility on this depending on how you drew your graph, and for the second one, it's about x equals 3.3. In this question, we need to work out the volume of a prism. We're going to use the formula, which is volume of a prism equals area of cross-section multiplied by its length. So we're going to start with the area of the cross-section. The cross-section of this prism is this L shape here, so we need to work out the area of that L shape first. We're going to do that by splitting it into two pieces. You can do this in two different ways, but for this question, I'm going to split it with a horizontal line here. I've now split it into two shapes. I'm going to call the first one A and the second one B. So let's focus on the area of shape A first. A is a rectangle, so we just need its base and its height. You can see its base here is 20, and the height is this one here, which hasn't been labelled. However, if you look across to the right, you can see it's the same as this 5 here. So the height of A is actually 5. So to work out its area, we need to do 20 times 5, which is 100. Now let's focus on B. So for B, we need the base and height as well. So if we look at the height first of all, you can see the height is going to match this 5 over here, so the height is also 5. But to work out the length of the base, this is a bit more difficult. Whenever we get a missing line like this and it's not immediately obvious which one it is, I like to ask, is it a vertical or horizontal line? In this case, it's horizontal. So if we look at all of the other horizontal lines in the question, we might be able to work out the answer. We've also got this horizontal line, which is 20, and this horizontal line, which is 14. This means we can find the missing length by doing 20 take away 14, which gives you 6. So the base of this one is 6 centimeters. So to find its area, we just need to do 5 times 6, which gives you 30. So if the area of A is 100 and the area of B is 30, we can add them together to get the total area of that cross-section, which is 130. Now we can go back to the formula. The formula said the area of the cross-section, we've just found that, that's 130, multiplied by the length. Now the length of the prism is this 8 here, so we just multiply the 130 by 8, and you end up with the answer 1040. In this question, we've been told the interior angle of a regular polygon is 168 degrees, and we need to work out the exterior angle. If we draw a quick sketch of this shape, the interior angle is the angle on the inside of the shape. So let's just draw one of those angles. It would look like this, and we've been told it's 168 degrees. To find the exterior angle, you extend the lengths of one of the sides like this, and this blue angle here is called the exterior angle. You can see from the diagram that these two angles make a straight line, so the angles on a straight line make 180 degrees. So to find the blue angle, we can just take the red angle away from 180. So all you need to do on this question is 180 take away 168, which gives you 12 degrees. So the exterior angle is 12 degrees. For the second part of the question, we've been asked to find out how many sides the regular polygon has. Well, there's a formula connecting the number of sides and the exterior angle. It's the number of sides is 360 divided by the exterior angle. And we've just worked out the exterior angle in the previous part. So we can find the number of sides by doing 360 divided by 12. This gives you 30, so it has 30 sides. For the first part of this question, we need to work out the vector 2a minus b, using the vectors we've been given here for a and b. So let's start with 2a. 2a just means we take the vector for a, which is -6, 5, and multiply it by 2. So we take two lots of the vector a. And then we're going to subtract from this the vector b, so we're going to take away the vector which is 2, -2. What we're going to do first is multiply that vector a by 2. To do this, you just multiply the -6 by 2 and the 5 by 2. -6 times 2 is -12, and 5 times 2 is 10. Then we're going to subtract from this 2, -2 still. Now this is probably the hardest step in the question. Now we're going to read along each of the rows and work out the calculation. So we've got -12 subtract 2, which is -14. Then if we look at the bottom of each vector, we've got 10, subtract, negative 2. Now if you're going to subtract a negative number, this is the same as adding it. So instead of 10 subtract negative 2, we can do 10 add 2, which is 12. So the answer to this question is negative 14, 12. You just need to be very careful with negatives in a question like this. For the second part of the question, we've been asked to draw some vectors. We're going to start with the vector, which is A. The vector A we were given at negative 6, 5. The top number tells you whether you're going to move left or right, and the bottom number is for up and down. Since the top number is negative, that means to move left. So it means 6 to the left, and the bottom number is positive, which means moving up, so it's 5 up. So we just need to draw a vector which goes 6 left and 5 up. So what we do is pick a starting point. I'm going to mark this with a cross, but you probably wouldn't do that in your exam. Then we go 6 left, then from here we go 5 up, and we put a cross there. So we need to draw a vector that goes from the first cross to the second cross. So all you need to do is draw a straight line in between them, and then make sure you get the arrow in the correct direction. We started in the bottom right and we ended up in the top left. So you place an arrow on that goes like this. So that's what you need to draw for your answer to the question. You don't need the dotted lines and you don't need the cross. For the second part, we need to draw a vector again, but this time it's 2b. So if we take the vector b, which is 2, negative 2, and we want 2b, we just need to double that. So we want 2 lots of 2, negative 2. If you double both of these, you get 4 and negative 4. So we need to draw that vector. This time we have a positive number on the top, so rather than moving left, we're moving right. And we also have a negative number on the bottom, so rather than moving up, we're moving down. So this vector is 4 to the right and 4 down. So we pick a starting point, we go 4 to the right, and then 4 down, and that's our finish point. So we just connect these up with a straight line, put on an arrow to indicate the direction that we went, and there's your finished vector. For this question, we've been given a number in standard form, and we're going to write it as an ordinary number. This one's 7.11 times 10 to the power negative 3. If you multiply something by 10 to the power negative 3, that's like dividing it by 10 3 times. So let's divide 7.11 by 10, and then a second time, and then a third time. So this is the answer to the question, 0.00711. For the second part of the question, we have two numbers in standard form and we're multiplying them together. If you have a question like this, you're first of all just going to multiply the normal numbers, so 8 times 3, which is 24, and then we're also going to multiply the parts with indices, so 10 to the 10 times 10 to the 3. If you multiply numbers with indices like this, you can just add the powers, so 10 to the 10 times 10 to the 3 is 10 to the 13. Now this number isn't in standard form, but the question does say to give your answer in standard form, so we're not quite finished yet. A number in standard form will always have the first number between 1 and 10, and 24 is bigger than 10. So we actually need to turn this into a 2.4, and to do that we divide it by 10. So 24 divided by 10 is 2.4, but if we're going to divide this by 10, we need to multiply the other bit by 10, so it balances everything out. So if we multiply 10 to the 13 by 10, we end up with an extra 10, so 10 to the 14. And that's your answer to the question. For the first part of this question, we need to expand and simplify a double bracket. To do this, we multiply everything in the first bracket by everything in the second bracket. So we're going to start by doing x times x. This gives you x squared. Then we do x times positive 2, which is plus 2x. Then positive 3 times x, which is plus 3x, and a positive 3 times a positive 2 is a positive 6. There's one more thing to do. We can simplify these x terms here. 2x add 3x is 5x, so we end up with the answer x squared plus 5x plus 6. In the next question, we're asked to factorise, which is the reverse process, so we're actually going to go back to a form that has brackets in it. We can recognise this as a quadratic expression, which means it's going to factorise into a double bracket. We first of all look at the end term here, a positive 24, and we think of numbers that multiply to make 24. So for instance 1 and 24, 2 and 12, and so on. Now all of those numbers I just said are positive, but we actually know since it's a negative 11x that they're both going to be negative. Remember, two negative numbers multiplied also gives you a positive. So we could look at negative 1 and negative 24, that multiplies to make positive 24, or negative 2 and negative 12, or negative 3 and negative 8, and one more, negative 4 and negative 6. So all of these will multiply to make a positive 24, but only one of these will add to make a negative 11. So if we add all of these together, -1 add -24 is -25, so it's not that one. -2 add -12 is -14, it's not that one. And -3 add -8 is -11, so it is that one. And we can just check the last one as well, -4 plus -6 is -10, so it wasn't that one. So the pair of numbers that multiplies to make a +24 but adds to make a -11 is -3 and -8. This means our brackets when we factorise will be x subtract 3 and x subtract 8. Now for the final part of the question we've got another quadratic, but this time we need to solve it rather than factorise it. However, in order to solve it, we're going to factorise it first. So just like we did in the previous question, we're going to look at the final term here, this -8, and we're going to think of two numbers that multiply to make -8. If we're trying to make a negative number, one of them must be positive and one of them must be negative, since a positive times a negative is a negative. So we could have 1 and -8, that multiplies to make -8, or 2 and -4. But we could also flip those round. So we've got 1 and -8, but we could have 8 and -1. And we've got 2 and -4, but we could have 4 and -2. All of these pairs will multiply to make -8, but only one of them will add to make a +2. So we add all of these together. 1 add -8 is -7, 2 add -4 is -2, 8 add -1 is 7, and 4 add -2 is 2. So the one we want is the final one since we're trying to get a +2x. This means if we factorise it, our brackets will be x plus 4 and x subtract 2. Now we haven't finished because the question didn't say factorise, it said solve. And if you notice, the extra bit of information we have here is this equals 0 on the end. So we put an equals 0 on the end of our brackets too. Now if the left-hand side of this is going to equal 0, there are two possibilities. Either the first bracket could equal 0, in which case x plus 4 equals 0, or the second bracket could equal 0, x minus 2 equals 0. Both of these equations are really easy to solve. For x plus 4 equals 0, you can subtract 4 from both sides and you get x equals -4. For x minus 2 equals 0, you add 2 to both sides and you get x equals 2. So the solutions to this equation are x equals -4 and x equals 2. In this question we have two similar octagons. If they're similar, it means one of them is a scale factor enlargement of the other one, so they're exactly the same shape, just possibly bigger or smaller. We need to work out the value of x, which is this side here. What we need to do is look at some of the other sides to try and work out how many times bigger the larger shape is. So if you see this 10 as the base here on the smaller shape, and this 15 as the base on the larger shape, we can work out how many times bigger the larger shape is. To do this, we'd just do 15 divided by 10, which is 1.5. This means the bigger shape is 1.5 times bigger than the smaller shape. In order to find x, we need to compare it to the same side on the other shape. So the same side on the smaller shape that matches with the x is this 8 here. We know that the bigger shape is 1.5 times bigger, so to find x we can multiply this 8 by 1.5. 8 times 1.5 is 12. So the answer to the question is 12. For the second part of the question we need to find the angle y, which is this one here. You can see that corresponds to this angle here on the smaller shape of 150 degrees. Now this is a bit of a trick question. Because the two shapes are similar, one of them is 1.5 times bigger than the other one, but that doesn't change the size of the angles. Even though you've enlarged the shape, all of the angles will still be the same size. So the answer to this one is actually just 150 degrees still. In this question we need to make b the subject of the formula. The subject of a formula is the letter that's on its own. You can see at the moment that r is on the left hand side on its own, so at the moment r is the subject. But we want b to be the subject, but b is on the right hand side and there's some other stuff on the right as well. We've got a 9 and a negative p. So if we take the formula, the first thing we're going to do is add p to both sides. If you add p to the right hand side, that'll cancel the negative p that's there. So on the right hand side you'll just be left with 9b. But if we add p to the right hand side, we must also add it to the left hand side. So on the left hand side we've got an r, and then we're going to add p. We can just write this as r add p. Now on the right hand side we've got 9b, but we don't want that 9 to be there, we just want it to say b. 9b means 9 multiplied by b, so we're going to divide by 9 on both sides. If we do that on the right hand side, 9b divided by 9 is just b, and on the left hand side if we divide by 9, well we have r plus p and we're going to divide that by 9. If we're going to write that algebraically, we'd write r plus p over 9. You can now see that b is the subject because it's on its own, so the solution to this is b equals r plus p over 9. For the first part of this question, we need to show that 8x plus 6 equals 70. If you look at this shape, it's a rectangle. You can see the top side is 3x minus 1, which means the bottom one must be as well. You can see the left side is x plus 4, which means the right side must be as well. In the question, we're told about the perimeter, which is 70 centimeters. Now, if we worked out the perimeter of this shape, we just need to add up all of its lengths. But we don't have its lengths as numbers, we have them algebraically. So let's add up all of the algebra that we can see for the lengths. We've got 3x minus 1, plus x plus 4, then we have another 3x minus 1 and another x plus 4. So if we added all of these lengths up, that is the perimeter of the rectangle. But we've been told the perimeter of the rectangle is 70 centimeters. So we know that if we added all of this up, it must equal 70 centimeters. All we need to do now is a bit of simplifying. On the left hand side here, we've got loads of x terms. We've got 3x plus 3x plus x. If you added all of that up, you do 3 plus 1 plus 3 plus 1, which is 8x. And then we've also got some constant terms, that's these numbers -1 plus 4, -1 plus 4. If you added all of that up, you'll end up with plus 6. And this equals 70. And if you have a look at the question, that's what we were trying to show. For the second part of the question, we need to find the value of x. This just means we need to solve the equation. So if we take the equation, we would take away 6 from both sides first. On the left hand side, this will cancel the 6, leaving you with 8x. And on the right hand side, 70 take away 6 is 64. Then we divide both sides by 8. On the left hand side, 8x divided by 8 is just 1x. And on the right hand side, 64 divided by 8 is 8. So the solution is x equals 8. Here we have an equation to solve, and you can see we have x terms on both sides. We call this topic solving equations with unknowns on both sides. When we have some easier equations, we're usually used to having the unknown or the x value on the left hand side. So what we're going to do is try and remove the unknown on the right hand side first. To do this, we're going to subtract 3x from both sides. If we subtract 3x from the left hand side, we have 7x take away 3x, which is 4x. But we don't take away anything from the 10, we just leave that as plus 10. On the right hand side, we have 3x take away 3x, which will give you 0, so we've just got this negative 14. It's important that you do include that negative still. That negative there belongs to the 14. Now we're going to subtract 10 from both sides like a normal two-step equation. If you do this on the left, we have 4x, and if you do this on the right, negative 14 subtract 10 is negative 24. Then you can divide both sides by 4. On the left hand side, 4x divided by 4 is 1x, and on the right hand side, negative 24 divided by 4 is negative 6. So the solution to this equation is negative 6. For the first part of this question, we need to fill in a probability tree diagram. We're going to start with the first section, which is about a 200-meter sprint. You can see from information in the question, the probability that she's going to win the 200-meter sprint is 0.9. So we need to work out the probability that she doesn't win this. To work that out, you take 0.9 away from 1. 1 take away 0.9 is 0.1. So the probability that she wins is 0.9, the probability that she doesn't win is 0.1. You can see they've already put the 0.9 onto the tree diagram for us, so we can just place the 0.1 down here. Now we move on to the long jump. You can see in the question we've been told the probability of winning the long jump is 0.8. So if we take this away from 1, we work out the probability that she doesn't win the long jump. 1 take away 0.8 is 0.2. So we have our probabilities for long jump, it's 0.8 for winning and 0.2 for not winning. So if we add those to the tree diagram, we've got 0.8 for win, 0.2 for not winning, and it's the same at the bottom, 0.8 for winning and 0.2 for not winning, since that's still for long jump. For the second part of the question, we need to work out the probability that Katerina wins exactly one of the events. So there are two ways of winning exactly one of the events. She could first of all win the 200-meter sprint, but then not win the long jump. Whenever we go across a tree diagram like this, we need to multiply the probabilities. So for winning the 200-meter sprint is 0.9 and not winning long jump is 0.2, so 0.9 multiplied by 0.2. This gives you 0.18. Now there is another way that she can win exactly one of the events. She could not win the 200-meter sprint and go this way, and then she could win the long jump. This time it's 0.1 times 0.8, which is 0.08. If you add both of these together, you get the answer to the question, which is 0.26. For the first part of this question, we're looking for the coordinates of the y-intercept of the line L. The y-intercept is just where the line crosses the y-axis. So you can see this line crosses the y-axis here, and the coordinates of that point are 0, -2. Now we need to work out the gradient of the line. To do this, I like to pick two nice points. By nice points, I mean points that go through the corners of a square. So this one here is quite a nice point, and so is this one. We then draw what we call a gradient triangle, which is a triangle that looks something like this. We now want to work out the horizontal distance and the vertical distance here. The horizontal distance goes from 1 to 2, so that's just 1. You need to be really careful here and not just count the squares. Even though that's 2 squares, it's still only 1 unit across. Then if we look vertically, you can see it goes up 3 squares, and it does go from 1 to 4, so that's 3. Then we use a formula for gradient, which is the gradient equals change in y over the change in x. The change in y is the difference that we went vertically, and the change in x is where we went horizontally. So vertically it was 3, and horizontally it was 1. So we're going to do change in y, which is 3, over change in x, which is 1. 3 over 1 is 3, and that's the answer to the question. One extra piece of advice here is that if the line slopes the other way, so it's going downwards, you'll do the same thing, but the gradient will be a negative answer. For the first part of this question, we're looking for angle x. If we draw on these lines here, you can see it makes a cross shape, which means they're the same size. We call these vertically opposite angles. So x is just 131 degrees, the same as the one that's opposite it. For the second part of the question, we're looking for angle y. Now this topic is angles in parallel lines. If you draw on this shape here, starting on a parallel line and then finishing on a parallel line, these two angles are exactly the same size as well. So y is the same as the angle that's 54 degrees. When you draw this Z shape, we say that these are alternate angles, and that's the answer to the next part of the question. It says give a reason for your answer to part B. We would say that alternate angles are equal. In this question, we've been given a universal set of numbers from 1 to 10. This means the only numbers we need to put into this Venn diagram are the numbers from 1 to 10. Then we've been given two sets. Set A is the multiples of 3. That's the numbers in the 3 times table, so 3, 6, 9, and so on. But we don't need to go any further than 9. Remember, the only numbers we need are from 1 to 10. Then we need the factors of 12. So we've got 1, 2, 3, 4, 6. And we don't need 12, which is a factor of 12, because it's not in between 1 and 10. Now we're going to go through each of those numbers and decide where they need to go. So if we start with the number 1, you can see that number 1 isn't in the set A, but it is in the set B. So we're going to place that in the side that's just B. Then we've got the number 2, which is in exactly the same place because it's not in A, but it is in B. Then we move on to the number 3. Looking at the list of numbers, we can see that number 3 is in A and it's in B because it is a multiple of 3 and it is a factor of 12. When it's in both of the sets, we place it in the middle. Then we move on to 4, which is in the list for B but not in the list for A, so we place that in the B only bit. Then we move on to 5, which isn't in either of the lists. Now if it's not in either of them, we place it in the outside part here. That's still inside the big rectangle though. Then we move on to 6, which is in both of them, so that goes in the middle. Then 7, which is in neither of them, so outside again. That's the same for 8. And then we move on to 9, which is only in set A, and it doesn't appear in set B, so we place that in the only A part on the left. And finally 10, which is in neither of them, so it goes on the outside. So there's your completed Venn diagram. In the second part of the question, we're going to choose one of these numbers at random, and we need to find the probability that this number is in the set A, and then this symbol here, which is a union symbol, B. A union B, we sometimes say as A or B. So we're looking for any of the numbers that are in A, or they're in B. So all of these numbers here. We then need to count up the numbers in here. We've got 1, 2, 3, 4, 5, 6 numbers. So the probability of selecting one of these numbers is 6, out of all of the numbers we could pick, which is 10 numbers. So it's 6 out of 10. For this question, you need to know your exact trig values. I'd recommend watching a video on how to learn all of these. I'll put one in the video description down below. So for the value of cos 60, you need to learn that this is equal to 1/2. And for sine 45, you need to learn that this is equal to square root 2 over 2. In this question, we need to try and find the region where the tower could be placed, and we're given some information. We're told it needs to be closer to point C than point D. To work out the area that's closer to point C than it is to point D, we're going to construct what we call a perpendicular bisector. To do this, you're going to take a pair of compasses and place them on C. Then draw yourself a nice big arc that would look something like this. Then without changing the size of the pair of compasses, and that's really important, you place the sharp bit at D instead and draw an arc there as well. So this arc will be exactly the same size. If we now join up the points where these two arcs cross over each other like this, you end up with this straight line. This straight line is exactly halfway in between C and D. So if we need to be closer to C than we need to be to D, we need to be on the left-hand side of this line, because then we're closer to C. Now we're also given some extra information. We're told we need to be within 350 meters of point B. But we've been given a scale 1 centimeter represents 50 meters. So we need to convert those 350 meters back to centimeters for our diagram. To do this, you divide 350 by 50, which gives you 7. So when we say we need to be within 350 meters of point B, on our diagram we need to be within 7 centimeters of point B. So what we do is we take our pair of compasses and set them so they're exactly 7 centimeters apart. Then take them and place the sharp bit onto B, and then draw yourself a nice arc here across the shape, something like this. Now once again, depending on how your document has been printed, you may end up with a bit of a different solution. Mine is done in the case where this is printed at full size on A4. So if we want to be within 7 centimeters of point B, we need to be inside this arc. So we need two things. We need to be to the left of the red line, but inside this purple line. The only region where both of them are true is this part here. So that's the part we shade in, and the tower must be placed somewhere in there. For this question, we have a sector of a circle, and the first thing we need to do is work out its area. There's a formula for this, which is theta over 360 times pi times radius squared. You'll notice this is really similar to the formula for the area of a circle. There's pi r squared, but we just have this theta over 360 at the front. Theta represents the angle in the question, so the angle for the size of the sector. This angle is a right angle, so it's 90 degrees, so we can replace that theta with 90 degrees. Then r is the radius in the question. You can see the radius from the centre to the outside of the sector is 8 centimeters, so we can replace the r with 8. Now you can just type this straight into your calculator and it will give you this number here. The question asks us to round it to one decimal place though, so this would be 50.3. For the second part of the question, we need to work out the perimeter of the sector. We're going to start by finding what we call the arc length, which is the length of the arc from A to B. To do this, we use this formula, theta over 360 times pi times diameter. This is really similar to the circumference formula, which is pi times diameter. Once again, we just have this theta over 360 at the front. Theta is still the angle, so that's still 90 degrees. But d is the diameter of the circle, which is double the size of the radius. So if the radius was 8 centimeters, the diameter will be 16. You can type this into your calculator and it will give you this number here. Now that's not the answer to the question though, that's the length of the arc. The question wants to know the perimeter of the sector. So we've just found the arc, which is this length here from A to B. So that's 12.566637061. The perimeter of the sector though will be the length of all of the sides. So you can see we've got this 8 at the bottom, and we've also got this side BO over here, which is also 8 centimeters since it's a radius. So if we were to do the perimeter of the whole sector, we'd need the 12.5666 and so on, and we'd also need to add to that the 8 and the other 8 for the other radius. So it's 12.566 and so on plus 8, which gives you this number here. Once again, we need to round to one decimal place, so this time it will be 28.6. For this question, we need to do 2y to the power 4 all to the power 3. When you raise something to the power 3, you multiply it by itself 3 times. So we need to multiply 2y to the 4 by itself 3 times. So we just need to do 2y to the 4, times another 2y to the 4, and times a third 2y to the 4. If we're going to multiply these, we'd start with the 2 times 2 times 2, which gives you 8, not 6. And then when you multiply y to the 4 times y to the 4 times y to the 4, you just add the powers. 4 add 4 add 4 is 12. So it's 8y to the power 12. In this question, we've been told the volume of a cone is equal to 30% of the volume of the sphere. We're going to start with the volume of the sphere, and we've been given the formula for that in the question. So for the volume of the sphere, it's equal to 4/3 times pi, and then it says times r cubed, where r is the radius. And you can see from the diagram we know the radius of the sphere, that's 5. So it's times 5 cubed. Now let's move on to the volume of the cone. The volume of the cone is not the same as the volume of the sphere, It's 30% of it. So for the volume of the cone, let's take the same thing we just did for the volume of the sphere, but find 30% of it. To find 30% of a number, you can multiply it by 0.3. So if you type all of this into your calculator, you'll find the volume of the cone, and it will come out at 50 pi. I'd advise you leave it in terms of pi at the moment rather than a decimal. It will just make the question a little bit easier. Now in the question, we've been asked to find the height of the cone, not its volume. So how are we going to do this? Well, we've been given the volume of the cone formula as well. So let's imagine just for a second we didn't know the actual volume of the cone and we were trying to find it. What would we do? We would do 1/3 multiplied by pi multiplied by r squared, where r is the radius. Now if you look over at the cone, you can see its diameter is 8 centimeters, which means the radius is 4. So we're going to multiply by 4 squared, and then we need to multiply by the height. But this is the point where we would become stuck because we don't know the height, so we can just call it h. But we do know what this needs to equal. It needs to equal the volume of the cone, which we found was 50 pi. So what we've managed to turn this into is an equation to solve. On the left hand side, if you type just this part into your calculator, it will come out as 16 over 3 pi. So we have 16 over 3 pi times by h equals 50 pi. At this point, you can cancel both pi's from both sides, so we just end up with this. Now to solve this equation, we can multiply both sides by 3. If you multiply the left hand side by 3, this will cancel the divide by 3, so you're just left with 16h, and on the right hand side 50 times 3 is 150. Now we divide 16 on both sides. 16h divided by 16 is just 1h, and 150 divided by 16 gives you this number here. So we've now found the answer to the question. The height of the cone is 9.375. It does say to give this the 1 decimal place though, so we should put 9.4. In this question, we're trying to work out the length of AC. So we're just going to label that x to remember that's the one we're trying to find. This is a trigonometry question, we can tell because we've got a right angled triangle here and some information about sides and angles. Next we're going to label the triangle. We can label the hypotenuse first, that's the longest side, the one opposite the right angle, so we put an h for hypotenuse. Then if we look at the angle in the question, that's the 81 degrees, and we look opposite that, we find the opposite, which is here. And finally, the one that's next to that 81 degrees that isn't the hypotenuse is the adjacent, so we'll put an a here. Now you can see when looking at this information that two of these are paired up. The a is paired with the 11 and the o is paired with the x, but the h unfortunately is all by itself, which means we don't need it for this question. This leaves us with just o and a. If you write out SOHCAHTOA, you're looking for one of these that contains the o and the a, and in this case that's the TOA. This means we need to use tan for this question. So we're going to write out the formula for tan. Tan of the angle, which is 81, is equal to the opposite, which we don't know, we've called that x, divided by the adjacent, which we do know, that's 11. In order to solve this equation, we can multiply by 11 on both sides. On the left hand side, if you multiply tan 81 by 11, you just get 11 times tan 81, and on the right hand side the 11s will cancel, so we're just left with x. If we now type the left hand side into our calculator, we'll end up with a decimal, so x equals 69.45126666. We need to round this to 1 decimal place like it says in the question, and that's 69.5. This question is also a trigonometry question, but we're trying to find an angle this time, the angle CAB. So let's mark on the angle CAB onto the diagram, so start at C, go to A, then go to B, you'll find this angle here. And we can label that x to remember we're trying to find it. Now let's go ahead and label the triangle. Let's start with the hypotenuse. The longest side that's opposite the right angle is this one. The opposite is the one that's opposite the angle in the question, that's this one. And the adjacent's the one that's next to the angle, so this one. This time it's the O that's by itself, so we don't need O for this question, we just need A and H. If we write out SOHCAHTOA, the one that has A and H in it is CA, so we need to do cos. So we can write cos of the angle, but we don't know the angle this time, so cos of x, equals the adjacent, which we do know, that's 8, divided by the hypotenuse, which we also know, that's 13. Now to solve an angle one like this, we need to use the inverse cos button, so we're going to do x equals inverse cos of 8 over 13. To type this into your calculator, you'll probably need to press shift before you press the cos button. Once you've done this, you can get the answer, which is equal to 52.02 and so on. And again, we need to give the answer to 1 decimal place, which is 52.0. In this question, we need to work out the perimeter of the kite. To do the perimeter, we need to know the lengths all the way around the outside of the shape. You can see we've got 2 of those at 78, but we're missing 2 more. Let's focus on finding this length here from D to C. We're going to do that by looking at this triangle here. The question says to give your answer in centimetres, and you can see for this triangle we've got the length from A to C in metres, so let's turn that into centimetres first. So 1.3 metres, if you multiply by 100, is 130 centimetres. Now looking at just this blue triangle here, you can see it's a right angled triangle, which means we can use Pythagoras' theorem to find the missing side. To do this, we square both of the sides, so 130 squared, which is this, and 78 squared, which is this. And then you need to make a decision, are you going to add those sides or subtract them? To make that decision, you're going to need to think about which side you're finding. We're trying to find this side here. If the side you're trying to find is the hypotenuse, the longest side, you add those 2 numbers. If it's not the hypotenuse and it's one of the other 2 sides, you subtract them. Now you can see we already have the hypotenuse, that's 130 centimetres, so we're going to subtract in this case. So this number, take away this number, which gives you this number. Now that isn't the length of that side, that should be fairly obvious, this number's far too big. The final step in a Pythagoras question is to square root this. So if you square root this, you end up with 104. So the length from D to C is 104. Now because this shape is a kite, the length from D to C is the same as the length from B to C. So this one's also 104. And now we're ready to work out the perimeter, we just need to add up all of the sides. So 78 add 78, add 104 add 104, gives you the answer 364. In this question we have some simultaneous equations. In order to solve these, we're looking to try and find a matching pair of x or y coefficients. If you look at the coefficients of the x, you can see we've got a 5 and a 3, so they don't match. If you look at the y's, you can see we've got a +4 and a -2. They also don't match, so we're going to need to do something to make them match. If you look at the -2 there, you could turn that into a -4 by doubling it. Then it would match with the y one. Even though the signs are different, as long as the numbers are both 4, that's okay. So what we're going to do is leave the first equation alone as it is, 5x plus 4y equals 41, but then we're going to double the second equation. We need to double all of the terms though. So let's double 3x, which is 6x, let's double -2y, which is -4y, and let's double 29, which is 58. You can now see that the coefficients of y are matching. They've both got 4s there, even though one's positive and one's negative. That's okay. Now we need to decide the next step. We're either going to add or subtract the equations. To decide this step, you're going to look at the signs of those coefficients. If the signs are different, you're going to add the equations. In our one, they are different. We've got a +4 and a -4. So they're different, so we add the equations together. If you do 5x plus 6x, you get 11x. If you do 4y plus -4y, you get 0, which is what we want to happen. And then we have 41 plus 58, which equals 99. So we end up with this equation, and you can see the y's have disappeared. 11x equals 99, we can solve that just by dividing by 11, and you get x equals 9. So we found part of the solution. We know that x equals 9, but we don't know what y is. To find y, we're going to pick one of the equations and substitute this x value back in. Let's go for the first one, 5x plus 4y equals 41. So we're going to replace the x in this with a 9. So instead of 5 times x, we have 5 times 9. 5 times 9 is 45, then it's plus 4y equals 41, and now we have an equation to solve to try and find y. We can subtract 45 from both sides. On the left, that will cancel the 45, so we get just 4y, and on the right, 41 take away 45 is -4. Then divide both sides by 4, and you end up with y equals -1. So we have 2 parts to the solution, we have x equals 9, and to go with that, y equals -1. For this question, we have some graphs and some equations that we need to match them to. You just need to learn these equations and their corresponding graphs. The line y equals x is a diagonal straight line, so that's actually just graph A. Then we move on to y equals x squared. This one's going to be a curve and it makes a U shape. Remember we did a quadratic graph earlier and that also made a U shape, because it's got the x squared there. So that's graph D. Then we've got y equals x cubed, which is graph C. And then finally y equals 1 over x. This is a really interesting graph called a reciprocal graph, and it comes in 2 parts. You can see that's graph B. Thank you for watching this video. If you found it useful, please like the video, check out the video I think you should watch next, and subscribe so you don't miss out on future ones.